Saturday Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
Data is a super valuable asset in today's business. Data-driven decisions means 23 times more success in attracting customers, improving the bottom line, and future-proofing the company. We understand your data, your business goals, and connects it to time-proven and disruptive technologies solving your pains. Welcome to the world of digital transformation. Data are the very heart of your company, and we provide you the best option for collection, storage, and analysis of your data, providing you with real-time insight and data decision-making. Seamless flow of data enables data-driven organization and is the basis for data democratization. We future-proof your company, leveraging data to extract the optimal value. Digital transformation requires all types of data you probably have. We gain insight to them with cutting-edge artificial intelligence and machine learning technologies. Artificial intelligence and machine learning bring data game on a new level, increasing exponentially the level of accuracy and prediction. Result: end of low-value, repetitive tasks. We provide you with end-to-end solution stemming from your business goals and leveraging data to understand and sell to your customer by delivering campaigns, marketing strategy, and UX UI. One-stop partner, global presence, data and AI-driven, marrying the best of business, technologies, and creative. Digital transformation with Adestra is your path towards data-driven future.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not auditing, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
first one under brand. I will not spend much time for introduction, just would like to make one big thank you to the whole team working on organization of this event. It was something really quite challenging to make a hybrid event with full-time streaming and also in-person event. And of course, I would like to say big thank you to our partners, because without our partners, it is not possible to have this good event. And because we are a little bit behind the schedule for the opening, I would like to invite John O'Connor, who will share some things about Adatis. So, John, you are welcome. I will just help you. Thank you, Michael. I will just help you with your presentation. Wonderful. And we'll share it. Please sit here and that will. Okay.
So, hello everybody and welcome. Thank you very much for joining us. So in case you don't know who we are Adatis. So we are, sorry, Misha, how do I move across the slide?
You can do it in this way.
This is our fourth SQL Plovdiv event. We're very excited to be with you. Sorry, just having some technical issues with the slides, but be with you. Yeah. So, so who are Adatis? So Adatis are a flagship Microsoft data and AI partner. We're a gold partner with 5 competencies. And what it is that makes us kind of a little bit niche and special is we have a large team now of over 150 employees. We're purely tied to Microsoft, and we've got a very close relationship with them. So we were a launch partner for Synapse, and our CEO also sits on the advisory council in Seattle. So we've got a really good, close relationship with Microsoft. And as a result of that, we get early access and previews to features, and we get to work on some really exciting projects with them. In terms of who we work with and what we do, we work across a variety of sectors: education, governmental, manufacturing, and entertainment. Hopefully you'll probably recognize some of the clients on here. So for example, the Stars Group, ASOS, who are one of the largest consumers of Azure resources in Europe. Obviously, we've got some government agencies like the Department of Education, also Heathrow Airport, who we've been working on very closely, also with Microsoft. So we've done one of the first implementations of Purview before that was readily available or in public preview. And in terms of the technologies we work with, traditionally it used to be the kind of on-premise SQL Server stack, so SQL Server and integration services, reporting services, all of that. And more recently, we've moved, I say more recently, probably over the last 3 to 4 years, we've really moved into working within Azure almost solely, because the larger clients really want modern data warehouse solutions based around modern technologies. So we're working a lot with Synapse Analytics, Databricks, tools like Purview, and ADF. We're also published authors, so we've recently done a book on modern data warehouse in Azure. We've also written about data warehousing and master datering techniques in the past. Now, that's what we do kind of technically, but I think what makes the data special really is the people. And I think, as you can hopefully see from the pictures here, Datus really is a people-focused company. And I really do believe that that is what makes Datus special. So I would really like to introduce you to Ellie, who is our new Bulgarian head of people.
Hi everyone, my name is Ellie and it's a real pleasure to be here with you today. It's my first Data Saturday event that I'm part of, and I joined the Datus over a year now, so it's been a great pleasure to be part of the company. What I'm here to talk to you about today is our vision, values, and culture. So a Datus vision is to be the data analytics company most admired for its people, culture, and innovation. And as you can see here, we have 9 values representing our people-first culture and the green in the middle. But what really makes our culture so special is how our employees describe it. So a Datus culture has been described as friendly, compassionate, caring, providing a lot of learning and growth. And in a Datus, your career depends entirely on you. We offer flat hierarchy with no door policy, where people can meet their colleagues, which will soon be friends, and also share a lot of knowledge. So if this is something that really sparks your interest, then I'm really excited to actually share with you some of our live positions at the moment. We have data consultants across all levels. We're also looking for senior consultants, Power BI consultants, and principal consultants. And in case you're wondering what is the work and life in a Datus, then I'm more than happy to actually share that. We also offer a mentoring program where you can have a one-to-one with your mentor, share knowledge and expertise, and also be guided in your career. But we also offer a remote work at the moment. So if you're in Plovdiv and if you're wondering, like, can I work in a Datus? Yes, you can. We offer working from home, and we're very glad to actually have our one consultant here with us today who will be able to tell you more about that. And also, I'll be around to talk to you and share more about our positions and where you can find us. So let me introduce you to Karina. Karina is our very talented consultant today.
Hi everyone, my name is Karina and I'm data analytics consultant. How it all started for me, I first met a Datus at the university. So they were guest lecturers in our BI subject, and we were tasked with assignment for creating dimensional model and a few Power BI reports. And while working on this assignment, I had the pleasure to communicate with them, and I would say that I was impressed by the level of their technical expertise, but moreover, I was impressed by the great care they took of each student. And shortly after that, I joined the company. Now it's been more than 2 years since I'm with the Datus, and work anniversaries always make me look back and think, am I happy? Did I develop as a professional? And I can confidently say yes. Now, there has been many memorable moments during the years, but if I need to pick only 2 or 3 of them that make my yes so confident, it's the people I worked with, the great mentors I had during that time, and also the interesting projects. Now, if you're keen to learn more about work and life at Datus, I'll be happy to meet you and speak to you. Thanks. Over to you, Jim.
Thank you very much, Kelly. Yeah, we're not really just here just to talk about ourselves or to show you pictures of our crazy team days, which we have 3 every year, 1 for each season, and then also the infamous Christmas party. We're also here to share with you some great content. So I would very much like to introduce one of our senior consultants, Vlad.
Yeah. Thank you for giving me the word, John. Funnily enough, I wasn't a senior in this picture, and now that I'm a senior, I've lost my hair and mustache, it seems. So today I'll be hosting the session Azure Purview from the field. It's going to be in this very room for the people that are in person. For those online, track 1. I'm going to share some of the stuff we've learned from working with Purview for nearly a year now. Actually, when I picked it up, it wasn't even called Purview. It was just Data Catalog v 2.0. Quite not as exciting as Purview. I'm going to show you around all the basics of the service and also look at some more advanced topics. So we're going to talk about how do we bring metadata in Purview, how we scan entities, how we can enrich that metadata with information provided by us, how do we implement business glossary in Purview, and we're going to also look at how lineage works in Purview. I have a very exciting bit during the session where we're going to look at how we've enhanced Purview using the APIs and really, I think, done some cool stuff with it. Oh, and there's going to be a prize for one of the lucky attendees in person during the session. So looking forward to it.
So in case you're wondering what the prize might be, those of you who've met us before probably know that the prizes will be hammocks. There'll be a chance for you to win a hammock in Vlad's presentation. There'll also be a chance for you to win a hammock at the raffle, which we'll be running at our stand, which will look something a bit like this. I'll go through quickly because I know that we're running a little bit over time here. But we would love to see you at our stand. So if you haven't spoken to us yet, or you have spoken to us and you'd like to speak to us even more, then please come over to the stand. It'd be great to see you there. Very happy to hear from you. Also, again, just to reiterate, if you're thinking about applying for a position, we are offering fully remote working positions. If you're interested, you don't have to be in Sofia. You can be in Plovdiv, be on the moon, wherever you like. Please don't let that put you off applying. Yeah, if you're there, we'll be at the stand. Be very happy to see you. And just a final thank you very much to everybody that's been involved in the organisation of this. Really appreciate all the effort and hard work that goes into it. I wish everybody a great SQL Saturday. Thank you.
Thank you to our partners from Adatis, and now we are very glad actually to invite in spirit and the person who actually started data community in Bulgaria. So we are very glad that Magi Naumova will present in spirit.
Hi, hello. And this time for this conference, I would like to actually practice my Bulgarian. So, здравейте всички и добре дошли на SQLSaturday Plovdiv. Радвам се, макар и отдалеч, да се видим и да така спазваме традицията, както в Пловдив, така и в София, да сме заедно по тези ивенти. Предполагам, че няма нужда да представям Инспирит в такава дълбочина. Може би с повечето и надявам се с повечето от вас да се познаваме. Работим вече повече от 10 години в областта на Data, SQL Server и Data Platform и със сигурност на всяка такава конференция имам какво да споделя с вас. Затова в това, което всъщност прави моят екип в момента, са точно неща, свързани с Azure Synapse Analytics, Purview и имплементация в клиентска среда. Супер интересни кейсове. Надявам се днес да успея да ви покажа някои неща, както и на ивента в София през октомври. За това ще се видим на моята сесия точно след 2 минути. Enjoy your data! И хубава конференция ви желая на всички.
And just Now we are very glad to invite our partners from DataArt and Denis Yuhno, who is the country manager of DataArt. Welcome, Denis.
Thank you. Thank you, Misha. Thanks to everyone. Thanks for everyone for joining. Thanks for everyone who are here. I just want to say hi from DataArt. We are global software engineering firm, and we have great news that this week we became 5,000 around the globe. So it's a very good achievement for us. We also, like, almost 5 years here in Bulgaria. We have physical office in Sofia, but as like it's modern trend, we also happy to welcome people from different cities, from Plovdiv, Varna, and other cities, because like we were like remote by nature even before this whole trend started. So like we open to remote work. Many thanks to the organizers. It's very great that it's possible to be present here physically, and also you can see the event online. So want to also thank to the DataArt team who like helped to organize the support of this event. So thank you all.
Thank you.
And have a great event.
And now I'm very glad also to invite the next partner, and this is Ivan Miluski, who is also speaker and good friend. Will say few things about company and why EPAM support this plan.
Hello everyone. So maybe most of you know that EPAM is a global leading product and service engineering company, and our goal is to provide the best in-class solution to our clients. We are trying to resolve most of the real-world cases which our clients are facing. Also, we are around 40,000 people around the world in 35 countries, and now we have a campaign which is related to Sofia, and we are expanding our data team. So don't miss to check out our offers, and also EPAM is one of the major sponsors of the events which take place in all over the Bulgaria. We also have some additional events which are related to the Jazz Talk. Also, we have a Drive One conference which took place for a few months in Plovdiv and also in Burgas. So don't miss out to check our job offers, and also enjoy the day. Thank you.
So I would like also to say big thank you to other partners who are not here in person. I would like to say big thank you to Adastra. Adastra support all our events, and we really appreciate this. I would like to say big thank you to Angel. Angel also support all our events last years, and it is really very important for the whole organization. I would like to say big thank you to Stripes. Stripes also has local presence here in Plovdiv, and it is one of the fast growing companies in Bulgaria. And of course, thank you to Microsoft, because most of sessions here are related to Microsoft technologies. But it is technology agnostic event. Just we started from Microsoft technologies, and of course support and strong presence from Microsoft is always appreciated here. That's everything which we want to share for the opening. We are a little bit behind the schedule with track 1, so I will wish you great conference, and I would like to invite the first speaker who actually will talk about very interesting things about Adatis and their technology expertise. So thanks again and enjoy the conference.
Azure Purview from the field. So a few words on how this will go. I'm going to start with a really short speaker intro in a second, where I will tell a few words about myself. After that, we're going to cover the basics of the Purview service and a few different user personas and how they can benefit from Purview implementation. And after that, I'm going to deep dive into the different capabilities of the Purview service. We're going to look at the data map and how we can ingest metadata into Purview. We're going to look at how we can enrich that metadata. We're going to look at the business glossary, the lineage, and finally, how to enhance Purview really through the REST API. The session will be very strongly demo focused, in the sense of I will mostly be sharing a demo Purview instance that I have created and populated to the slides. So before we go to what is Azure Purview, a few words about myself. My name is Vlad Gankov. I've been in IT for nearly a decade now, and I think the last 3 or 4 years, maybe a little bit more, I've been dedicated to data. My first encounter with SQL Server kind of led me into the space, and ever since then, I've been hooked. It's really fun technology to work with. For the past year or so, I have been working with one of the bigger data clients, and as part of that work, I've had the pleasure and privilege to implement Purview. Well, back then it was Azure Data Catalog v2. It was renamed. It's a very dynamic technology at the moment, as evidenced by the update which was pushed by Microsoft 1 week before this demo, which led to quite a few changes in the environment. But thankfully, I've managed to overcome them. So without further ado, what is Azure Purview? If you were to ask Microsoft that question, they would answer that it is their unified data governance service, which helps you manage your data, regardless of the source it's coming from. You would easily be able to create a holistic map of your data landscape and enhance it with end-to-end data lineage and data classification and business glossary. I'm going to agree with that with a little caveat. I've had to work quite a bit with the API to get the end-to-end lineage to work, but it's a part of the demo. We're going to see how that was done. There are really 3 core parts of the service, which are the Azure Purview data map, which is the bit of the solution which governs the ingestion of data from various sources, or the ingestion of metadata. We're not at any point ingesting any data into the Purview service. This is a question I've had a lot from clients. While Purview does sample some of the data that's going in, it doesn't store anything in the service other than metadata. So we're going to look at that part. The next bit is actually the core of the service and where most users will interface with the product. It's the Azure Purview Data Catalog. It's where we can view the metadata of the assets that we've scanned into Purview, and where we can do all of the value add of Purview is in the data catalog section of the tool. And I'm going to go into detail into all of this in a second. And finally, we have the Azure Purview Data Insights. which is where we can gain some insights over our data from predefined dashboards from Microsoft. This bit really is changing constantly, and at the moment is marked as preview in the interface itself. I'm going to demo that as well, but have in mind that that might change a lot by the time the service goes in general availability, which, by the way, is due to happen next month. So fingers crossed. So this is the last slide before I move to the practical demo, I promise. So what's in it for you? There are a few user personas defined really by Microsoft, and depending on that, there are different benefits you can gain from the service. If you are a security officer or kind of a top-level data officer, maybe you want to understand exactly what you have in your data estate. There are some very handy scripts provided by Microsoft, which you can use to grant the Purview service access over your, say, entire Azure tenant, and then scan it and pick up every bit of data that is there. So bye-bye shallow IT. And the other bit is through the automatic data classifications that Purview has. Opportunity, although there are a lot of ifs here, which I will go into detail a little bit later. You can discover which entities contain PII data or other sensitive and protected data that you must be wary of. Of course, Purview is using some sort of algorithm behind the scenes to do that, and that algorithm sometimes has gaps. We're going to look into that. Now, if you're a data producer, we've all done this documentation. It's a pain. With Purview, you can kind of get automatic documentation of what's inside your database, all of the tables, the fields, the metadata. It makes creating data dictionaries much easier. And with the added capability of putting business glossary on top of that metadata, you can really create a single source for documentation for any data, should I say, data solution. And lineage. Lineage, at least for me, as a person working in data, is quite a benefit, because it makes tracking an entity from ingestion all the way to the end report, presumably in Power BI, very easy to track, which is also a very big benefit for data consumers. If I was given a penny every time an analyst asked me, where is this calculation coming from? How did you get this number? Which is the source table? I would be a millionaire by now. And thankfully, with Lineage, this bit is made much easier, and it's really, it becomes a self-service capability. You just go in the tool, find the entity, and you can track it across all the stages, which coincidentally makes data exploration much easier. The solution that we're working with, or shall I say the application landscape that I'm working with Purview at the moment, we have dozens, maybe over 100 data analysts working with hundreds of applications, and finding every single bit of data that can help you create an analysis can be very difficult if you have to rely on kind of company hearsay and outdated SharePoint docs. Whereas with Purview, all this is at like a few clicks away, provided you have gone through the setup of Purview. Okay, and of course, ultimately, this makes collaboration much easier for everybody involved in using Purview. I am going to go into detail into a few of the core bits of the Purview service, but for that, I'm going to stop with the slides and move with the practical demo. So bear with me for a second, please. Share screen, share the entire screen. And if everything has gone correctly, which it seems that, yay, okay. Let's go into the actual Purview Studio. So, Azure Purview, it's deployed as a standard resource in Azure. It's got its own managed service identity, and that is important for data scanning, which is the first bit I'm going to talk about. I am going to go into the interface of Purview and in the data map menu. This is the screen from which we can register sources of data in the Purview service. And this is how we can set up scanning of these entities. So what a scan does is essentially, provided you have given the Purview service read permissions over the entity you are scanning, whether that's, oh, good point, what kind of entities can we scan with Purview? For the Microsoft data stack folks, that's literally everything. So blobs, data lake, Azure SQL databases, Synapse Analytics, Power BI datasets, on-prem SQL servers, Azure Data Factory, you name it. If it's part of the stack, it works with Purview. And it also supports a bunch of non-Microsoft sources, such as Oracle, Teradata, Amazon S3 buckets. With the latest update, I've seen that Google BigQuery is in preview, and the list is evolving on and on. Probably by the time you go and view the list in the Azure Docs, it will be different from what I'm saying right now. So we give the Purview service read permissions over the entity we are scanning, and then we have to register it in a what is called a collection. Think of the collections as containers. The only purpose of the collections is user access control. Previously, the way this worked is users would be added to a Azure IAM, Identity Access Management, I think it was. You would add the users as Purview data readers, and they would be able to read everything inside the Purview service. So any entity that was scanned, you would be able to see it. With the latest update, after feedback coming from a variety of sources, Microsoft have changed this, and now we have a per collection security model. So you can give some users access to one collection, but not give them access to another collection, which is very neat. So inside the collections, we register the data sources, and it cannot be simpler. I'm going to demo it live. You hit register, choose one of the supported services, provide the necessary details, and hit register, and you are done. After that, setting up a scan, which will, as I said, read all the metadata from that entity and bring it in, is as simple as going inside the newly registered data source and hitting new scan. Sure. For most entities, Purview supports scoped scans. So maybe if you're scanning, it depends on what you're using the Purview service for. But let's say the goal behind your Purview deployment is to empower your data analysts and have them discover data much more easily. In this case, probably if you're scanning a data warehouse inside Purview, you don't want to bring all the staging tables and all the things going behind the scenes. Maybe you just want to scan the views which actually hold the facts, dimensions, and whatever, like the meat of the data warehouse. You can do that. So Purview supports scope scans of the different entities. Very important bit. If you're scanning on-prem sources, let's say you have an on-prem SQL server that you want to bring into Purview, this is absolutely possible. Purview now supports scanning of on-prem servers using the same self-hosted integration runtime that we all know from Azure Data Factory. It's literally the same process. You register the integration runtime in Purview, you download the binary, install it in a VM, give network access from the VM to the cloud, and you're ready. Purview can now scan anything in your on-prem environment. Classifications and classification rules are something very neat, which we're going to cover in the next bit of the session. There's a few other things I want to go around scanning before we move into that. So I have not forgotten. I'm intentionally skipping that bit. And yeah. Oh, I want. Yeah.
Can I ask a question? So,
yes.
What are the permissions required to do the scanning? Is it like just a reader, let's say storage account?
Exactly. It's the equivalent of read permissions for the entity you're scanning. If it's a storage account, it's a storage blob data reader. If it's a database, it's a DB reader. If it's Power BI, you have to go in the admin settings of the Power BI tenant and manually add the Purview managed service identity. If you're not comfortable using the Purview managed service identity, you can create a user managed service identity and register it in the Purview service and use that for authentication. If you want to use...
so it's using the main APIs of Power BI, or I have to add it in all workspaces? And
admin APIs. There is a setting in the Power BI admin portal, and basically you add the Purview managed service identity to a security group, and you give access to the security group.
okay. Yes.
Just. Oh, and by the way, as evident, all questions are welcome. We also have a small time for Q&A at the end of the session, but do feel free to interrupt me at any time. So yeah, security, back to security. This was one bit which I wanted to cover, thank you. And the other bit was around what kind of permissions users have inside Purview. It's really simple. As I said, the permissions model is per collection, and there are only 3 roles that exist in Purview. Purview data reader, which allows a user to read anything in the collection, but they cannot modify or enrich the metadata in any way. They're simply consumers. If you want to be able to enrich the metadata, so provide descriptions, turn the metadata into kind of a data dictionary, or tag it using business glossary, or anything like that, we have the Purview Data Curator role. And finally, and this is very neat by Microsoft, there is the Purview Data Source Administrator role, which doesn't have any permissions to read anything in the Purview service, but can add, can register sources and set up the security around scanning data sources. So, likely give your DBA or a person like that data source administrator access, and they would set up and register all the sources for you, and then all the other users would be either readers or curators. Yeah. So the next bit, now that we have covered data sources and scanning, is actually the meat of Purview. Let's look at how an asset, they call it in Purview, how an asset looks after you have scanned said asset. Regardless of the source type, there is a common screen for all assets, which kind of has the same structure and same fields. Let's explore something. So we can browse the assets by collection or by source type, or we can simply search if we're into that. A couple of words about the demo. I have set up Azure SQL Server, Azure Synapse Analytics, Blob, and Data Lake with some dummy data in them, and did some dummy, it's really just a copy activity in Azure Data Factory. So not all of the fields will be populated, but it's a great way to experience the capabilities of Purview. All the data sets are from Kaggle. So let's see, what have I brought in here? I'm not sure if you can read. I will zoom a little bit for this bit. At the bottom of my screen, one thing I missed about scanning, and Purview is very smart in this way. Frequently, when we are ingesting data and landing it in some sort of blob or storage, we format the file paths using year, month, day, or some sort of breakdown per time. Purview is smart enough and captures this structure and abstracts it away from the entity. So if you're downloading, let's say you're copying a table of a database into a data lake every single day, and you have a year, month, day structure, Purview is not going to create 7 million assets, one for every single day that you've ingested that file. It will abstract that away, and it will create a single entity, single assets, which represents all those files. And it will have the latest schema available. Actually, the bit which does that is extendable by the users of Purview. So you can define such patterns yourself and abstract away, say, locations in the file name or any sort of path patterns, which is very neat. I think. So that's the overview screen of an asset. We could provide a description or classifications for that asset. I'm going to cover the classifications in detail a little bit later, so stay tuned for that. Same with the schema classifications. Let me just quickly go into the properties. So there are a few built-in properties for every asset, and you can extend that a bit with the API. You can create custom objects inside Purview. So programmers rejoice. And let's see if I can zoom out a little bit. I hope it's still legible. For every asset you bring in Purview, it will infer the schema from the asset. That's way more easily done if it's a database table, because the schema is part of the table, in the sense of Purview can just query the database and get the schema from it, and you will have the data types there. In case of flat files, it samples them and infers the data types sometimes. So in this case, we can see for this CSV, we have all the columns. And even, let's go into the classifications. Purview has a classification engine. So whenever it's scanning an asset, it is sampling the top n amount of rows, where n can be a different number depending on the asset size and row count. And using a built-in classification engine is automatically classifying the columns with predefined classifications. There is a full list of these on the Microsoft documentation, but just to give you a sense of what it is, as we can see on the screen, it can infer things like country or region. It can find the latitude and longitude and tag columns with that. It can infer things like credit card numbers, identity card numbers, passport numbers, social security numbers. There is a variety of pre-built classifications. Fortunately or unfortunately, for most of these, what's going on behind the scenes is regex. So you can imagine that this is prone to error. Yeah, we've had a very funny case where the raw IDs of a file we were ingesting happened to have the exact same structure and length of the French identity cards, and half our database was tagged as PII sensitive and so on and so forth. It was funny. These classifications, they are, so first of all, you can switch that off if you don't want Purview to do that. And second of all, you can extend that. You can absolutely put your own classifications and apply them when you're scanning entities. I found this very neat when, for example, I don't know, off the top of my head, you're working with an airport. The flight number always has the same structure. You can create a regex which captures the flight numbers, and then have every single column that has a flight number in it tagged as flight number. Actually. And to do that from here, which is why I skipped this bit earlier, there is a full list of the pre-built classifications here, and the rules. Unfortunately, we can't see the regex which Microsoft are applying here, but we have it in the documentation. And here we can create custom rules. So I can say custom demo classification. And now I can create a new rule on that. So custom rule demo. It will put this classification if the rule is met, and I can choose between a regex or a dictionary for that rule. And there is a bit of tuning on how the rule will be applied. So really quickly, I'll go over the business glossary. We have time.
Can I ask another question? What are those custom source types? What can you do with those?
So these custom source types, good question. I'll cover them in a second. They are part of the lineage, which is the qubit. I have created some custom objects inside Purview because out of the box, it doesn't support some things, or when it supports them, it doesn't do them in the way I want it to do them. So I've extended it a tiny little bit. Oops, sorry, wrong screen. So manage glossary. What we can do here is create custom terms. There are no predefined terms because every organization's glossary is specific to that organization. So if you want to use this bit of Purview, it's absolutely up to you to implement it. You can create terms and apply them to the assets that you've scanned in Purview. So I don't. I'm gonna create the term flight. Or let's use something more recognizable. Let's use HR, human resources. We can provide synonyms or acronyms for that. So say HR, and let's tag something. Okay, I'm going to tag it for the other screen. We could provide a definition for this term and then associate assets with this term. So I could, in theory now, go and for every asset that I have scanned, which is related to the human resources department, I could tag it with this department and say provide a contact, whether an expert or a steward, or provide other information which is related to that asset. It's also really useful for overloaded terms in the organization, for things like where client and customer is the same thing, or client and customer is a different thing, or where marketing and sales are calling something one way and the technical people are calling it another way. You can abstract that using the glossary and tag entities with tag assets with the appropriate business glossary, which would make them search inside Purview much easier. What we have also done is tag assets using tags which denote the curation stage of that asset. Say you're scanning your entire data lake and it's full of intermediary entities, the raw data that has been landed from the source, any kind of intermediate transformations. Maybe you want to tag those with some tag which shows the users that this is not the final stage of the data, and that if you're a data analyst, maybe you don't want to care about that data, maybe you just want to care about the curated data, which the data engineers have gone through the trouble of fixing it for you. Or maybe you don't, maybe you're a data engineer and you're intentionally looking for the raw source of some data, or a data scientist which wants to find, like you don't want to look at the table that's in the warehouse, you want to find the raw source because maybe you can use it for some model that you're developing. And now, for what you asked me, lineage. Out of the box, Purview supports, and this really changed with the latest update, Purview supports, so when you're bringing assets in, Purview will infer the parent-child relationships of assets. And what I mean by this is, let's say for an example, you have a Power BI data set, and from that data set, you have created a couple of reports, a few dashboards. Purview will infer those relationships and it will display them graphically. So it will show you this data set creates this and these reports. So let's show them. Okay, and same with ADF, data factory copy activities and data flows, mapping data flows. They are supported by Purview and it will automatically bring them in. At the moment, however, for reasons that I don't have time to go into, I am not using the built-in Purview Spark lineage. I have created my own custom source type and I'm driving the lineage of that. But in theory, it supports lineage from Spark transformations, which for us mostly means Databricks notebooks.
How to do that? The custom source type.
Yep, REST API. You need to create a service principal, give it Purview data curator access, and then you can use it to fiddle with Purview. In reality, behind Purview, for those that have used it, behind Purview you have an implementation of the Apache Atlas 2.0 API. So Purview is 100% like it supports everything you have in the Apache Atlas API, and it's extensible. So you can register your own objects and really do anything and more than what you can do with the graphical user interface, which is what I'm showing right now. So for an example, Purview doesn't support at the moment the lineage through stored procedures. So you have a stored procedure which is taking some source tables and spitting out a fact at the end of it. Purview doesn't capture that by default. I have created these custom object types to represent these processes, like a SQL stored procedure. And I've implemented them. So let's see how that looks. This is really, I find it's the best part of the presentation, not that I'm touting my own horn. I kind of am it. So let's go here. Actually, let's find it from an asset. Let's find an asset rather than this thing. So I'm going to go in Synapse. I'll go here. It's also useful for data exploration. If you're an analyst and you don't know the solution, if it's been tagged properly, it's probably easier to explore it from Purview rather than look at the database. Or should I say in conjunction with looking at the database. Now, the lineage screen at the moment is very small. I'm going to zoom it a little bit. Because what I've done here is, so this bit is coming out of the box. We can see that the Adatis Managed Services internal reports Power BI report, which is in this workspace, is derived from the Adatis something else Power BI dataset. We have a link to Power BI, so you can directly open it in Power BI if you wish to, or you can switch to the asset and it will take you to the asset page. Further, this is the custom object that I implemented. It represents the link between the facts and dimensions and the data set. Then this bit is representing the stored procedure with which this fact table is loaded. So we can now know that fact table 1 is loaded by the stored procedure called merge fact 1, which is sourced from this SQL table, demo table 3, which if we wanted to explore, what is this table, we can go in here, view its schema, view its overview. Aha, it's in the stage schema of the warehouse. And then we can look at its lineage. So I was in here previously, and I'm going further left. This was transformed by or loaded, should I say, by a Databricks notebook called this way, which is sourced from this CSV file, and so on and so forth. We can go back up until what ultimately we go to the initial, I hate this initial entity or the source really of this table, which is a file in a blob somewhere, which was initially copied by this copy activity, this data factory. And if I were to click here, it's actually going to go and open the pipeline in ADF for me. Another very neat use case I have found for us is that we put the links to Git in the procedures and notebook objects. So at any point you can view either the schema of the asset, or you can look at the code which is actually working with the asset. This is a really simple demo. So we've got a few tables being transformed up to the where was the Power BI? To the Power BI dataset. But you can imagine if you have a full-fledged data warehouse, this screen is way more populated with a lot more relationships, and it makes it really easy to unpack graphically the dependencies between entities. Yeah, it looks like this because the Power BI dataset is actually sourced from 3 tables from the Synapse warehouse, a fact and 2 dimensions. And we can see the lineage for all of them in one screen. And it would be the same if we had more entities. What I'm working with has dozens of facts and dimensions which are loaded from hundreds of source tables, and the visualization looks very neat. But unfortunately, it's a customer environment and I cannot present it. We have something else at the end. Oh, REST, yeah. As I mentioned, this is fully extensible using the REST API. Yeah. Any language can query it, yeah.
So what if my data state is 70% Azure, and then I have a bunch of other Facebook like Informatica, or I have some strange database engines that I don't support? Can I extend it, or I need to wait for Microsoft?
You have both options. What we did initially is we just extended it with whatever we needed. The one bit that you're, there is only one small thing which you will miss by not having the out-of-the-box data scanning, which is when you scan an asset, let's say, okay, data lake storage, this is a good example. To get this neat screen, which is copying the structure of the asset, I had to click scan once and it did everything for me. It looks like it's just a bunch of assets, but behind the screens, there are a lot more objects and relationships going on. If you want to have this cool screen, you're going to have to recreate all of that. But other than that, like, you're not missing anything by using the API. Yeah. Databricks notebook. I can show it, yes. So what I've done is, because personally I work with Python the most, and there is a very neat wrapper around the REST API. Sorry, before I go into that, I want to finish answering the question. So you can either wait for Microsoft or you can extend it on your own. Anyway, if you want to get the absolute most of Purview, I would advise you to use the built-in scanning and then enrich Purview through the API. Because at the moment there is no real backup or disaster recovery. So for us, we have found it the the easiest to just keep most of the enrichment we've done in a separate database, and we just populate Purview using the API. So even if we were to lose the resource, we can just repopulate it. And this was also very useful because Microsoft, because as I said, we started using it in private preview. Occasionally, they do such changes which require us to tear down the environment and recreate it. This has mostly gone away now. I don't imagine they're gonna do another big update like the latest one. As I said, like Purview is due to go in general availability next month, but still. And
Thursday, 27th September. Yeah.
And yeah, I wanted to really quickly show there is a very neat Python package, PyApache Atlas, which was written by one of the support engineers at Microsoft, and it abstracts the API away, and you can work with very, very, very simple Python code with the API, which is my flavor of choice, and it's how I've populated and set up the lineage for this demo. And it's also what we're using in production to drive Purview. Really. It is extremely simple. You create some very simple objects and push them using, where was it? Yeah, client upload command. I love it.
So basically, if you're using a non-supported or not out-of-the-box source, we take from this code book, this wrapper, and then just all the things yourself, and use Purview to just visualize and map the whole thing.
Yeah. Or if you're a better programmer than I am, you can use any programming language of your choice. For me, it happens to be Python.
So there's no actual dependency on what the actual source can do. Does it support REST API calls or anything like that?
Yeah, it's not dependent on the source in any way. You're populating Purview with metadata, so if you can capture that metadata in another way, there is nothing stopping you of pushing it into Purview. Yeah.
Thanks.
There is one last thing about the lineage, which I didn't mention, and I'm going to conclude the presentation after that and take questions. What now is the entity level, the lineage, like, yeah, the lineage between assets, or at, say, the table level or file level. Purview absolutely 100% supports lineage at the column level. So you can take, where was it? This thing, data set. So yes, it reads the schemas of Power BI datasets. Absolutely nothing is stopping you from creating the lineage between a single Power BI measure and all the columns that ultimately take part in the calculation there. It's a lot of work, however, and I don't have it in a demoable state. Not in the least because the capability of viewing Power BI schemas was released last Thursday.
And still in preview, right?
Still in preview, yeah. Still in preview. Pricing still hasn't been announced because I've been asked this question a lot of times by customers.
On the preview?
Yep.
Is it lower than now or higher?
I hope it will remain the same, but I can't answer because the pricing model changed a little bit. At the moment in preview, scanning SQL servers and Power BI is free of charge in Azure, which is very neat. And then the API is like using the catalog itself is not very expensive. But if you were to go in the Azure Purview pricing page right now, you will see a lot of to be announced there. So I can't take any questions on that. My talk has finished. I am going to take any questions the audience has, or if we have anything in the in the chat room. No questions in the chat room, sadly. Then questions in the audience. I know
I'll ask over years.
it's okay. Yes, yes. It does help the flow. Nice. Then, if we don't have any further questions, I will conclude my first but not last presentation at a Data Saturday. Thank you. And we have the hammock winner. The hammock was going to the person who asks the most or the most interesting questions.
I was the only one asking questions.
Well, then you don't have competition. Okay, that wasn't so bad.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Data is super valuable asset in today's business. Data-driven decisions means 23 times more success in attracting customers, improving the bottom line, and future-proofing the company. We understand your data, your business goals, and connects it to time-proven and disruptive technologies, solving your pains. Welcome to the world of data are the very heart of your company, and we find you the best option for collection, storage, and analysis of your data, providing you with real-time insight and data decision-making. Seamless flow of data enables data-driven organization and is the basis for data democratization. We future-proof your company, leveraging data to extract the optimal value. Digital transformation requires all types of data you probably have. We gain insight into them with cutting-edge artificial intelligence and machine learning technologies. Artificial intelligence and machine learning bring data game on a new level, increasing exponentially the level of accuracy and prediction. Result: end of low-value, repetitive tasks. We provide you with end-to-end solution stemming from your business goals and leveraging data to understand and sell to your customer by delivering campaigns, marketing strategy, and UX UI. One-stop partner, global presence, data and AI-driven, marrying the best of business, technologies, and creative. Digital transformation with Adestra is your path towards data-driven future.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
DataArt is a global software engineering firm with a uniquely human approach to solving problems. We have teams of highly trained engineers with over 20 years of experience. Everyone upholds a deep understanding of the industry sector through ongoing technology research. People first. Relationships are the foundation of long-term value generation. We hire people for the long haul. Projects change, but our employees remain with us. Commitment to people is the main and absolute value for DataArt. Data art doesn't have a rigid hierarchy with a single leader. The flat and decentralized organizational structure is beneficial to data art's flexibility. Data art's organizational structure is based around projects. We enjoy flexible schedules, vacations, and work locations, both at different developmental sales and centers, or from home. Data art is built around people who want to earn a living using their professional skills and talents with minimal limitations on their personal freedom. A lot of people are happy to work for data art and stay with us for many years. They have the opportunity to learn, gain experience, and grow. Join data art.
Hold up.
A second, and there we go. Yeah, you're right.
Okay, so let's see, all okay? We get started, perfect, okay. Very professional, perfect. Okay, welcome everyone. This is going to be the next session, which is going to be about quantum computing and anything quantum, actually, not just quantum computing. And we'll give you an introduction to all of the things you can expect. Not today, not tomorrow. Well, you can start today already, but in the next, year or so, to actually prepare for what's coming in the future. So we have some victims here in the audience as well, not just remotely, and they are joining us here in person because they are very brave enough to be in this quantum session. So thank you for being here. Hope this is going to be interesting. And the first thing I'm going to ask is, how many of you have tried this before? Okay. I usually ask this about most technologies, but I know that this one was a question I will not get an answer to, but this is fine. Anyway, I also want to thank Stefka for being here and moderating the session, so thank you very much. So let's start. So this is my cat. I usually show these slides at the beginning of most sessions, and I've been here before in Bulgaria. Actually, almost 30 times. I'm not sure the exact number of sessions that I did, but it's more than 25 and close to 30. I'm not sure the exact number. I lost count somewhere last year because something strange happened to the world, so I kind of stopped counting things for some weird reason. Anyway, today is not going to be an exception, and we'll talk about quantum. Please don't worry, because there's going to be something called theory in the title of the session, and yes, we're going to have some of that, but I want to show you the practical way of doing things as well. Okay, not so much, but to understand how quantum works, especially some parts anyway, we need to understand the theory. And don't worry, you don't need to know the relativity theory and things like that. Well, you should, but it's not such a bad situation. If you understand what a bit is, zeros and ones, etc., we can transpose that to what's expected in the quantum world, and we can try to simulate something like that. There's actually multiple ways of doing quantum computing and using, very, very small, particles, so that we can do computing, optimization, actually storage of information if you want, transfer of information also. There's going to be a lot of different ways to do this. Most of them have not been invented yet, so we'll see in the next few years a lot of things will come along. A lot of different vendors for technology, like Microsoft, IBM, and a few others, are working on different, hardware options to do all of this. But the practical thing is, okay, we are here, we have to work with programming, we have to work with machine learning, we have to work with databases, I don't know, we have to do queries, we have to do stuff. What's that for us? How can we actually use that kind of thing for us? Well, you shouldn't expect something like a quantum query, like select star from quantum table 1 just now. This is something that I expect that in the future will be available. And the reason for that is that what I'm going to show you today is going to be the building blocks for how things work. In the past we had the building blocks like bits and things like that, and we have for quantum we have the exact same thing. Okay, so let's see how this works exactly. So first of all, thank you very much for the organizers for being here, for the food. Obviously the food is not for anyone remotely, sorry about that. It's only for people who are here, but in any case, hopefully we'll see you in person in the next event or so, if you are remotely. If you are in person, come again next time as well. That's going to be fun. Okay, and who am I? Well, I'm this guy, and if you are from here, from Plovdiv, you're probably familiar with this word statue. Hello, welcome, very good to be here today. Thank you. This is a session I can say people are very brave to be in. It's a scary title. Anyway, but if you know Plovdiv, you know that the statue is there. And this was me, I have no idea when, but maybe 2017, 2018, something like that. And if someone is listening to me, I'll just complain or do something. So I'll be happy to do that. But feel free to contact me on social media and LinkedIn and things like that. I'll be happy to talk to you about not just quantum, but other things like machine learning and SQL Server, hacking, No, security, sorry. We have to call it security, otherwise you go to jail. Anyway, let's talk about this. So first of all, because you are here, I expect all of you to be this intelligent. No, don't worry, not that bad. So, anyone know who this is?
Sheldon.
Okay, so this is Sheldon. Okay, a lot of problems with this person. This next one you probably know already, right? Very unfamiliar person. It's a black and white photo, so that means this guy's really old, right? This is obviously Albert Einstein. This is his very big tongue, so we have to measure it. We can use centimeters and define the size of the tongue corresponds to the size of the brain. He had something like 160 IQ, I don't know, something like that. So it was big enough to come up with the theory of relativity and understanding how small quantum particles work, etc. I don't know half of those things. I will never be able to understand those things. It's just very difficult. I could try if I went into physics, but I work with computers, and the most advanced thing we do in computers is, turn off and turn on again, right? This is the most advanced thing we do. So we need to understand how we do those kind of things in the quantum world to turn on and off things. And from that point on, bits on and off, things will just work, right? Okay, so there's also another guy that I've decided to add. I could add a lot more, like, a guy called Schrodinger. You probably heard of him, but other people, Heisenberg, etc. But this guy is Richard Feynman. And this guy is actually very famous. He's a good communicator. He died in the 80s at some point in time, but he was actually a part of the, those things in Los Alamos during the Second World War, and those kind of things. And he interacted with a lot of people. And he actually wrote a book that I read when I was, I don't know, 15 or less, something like that, which is actually this name. And no, it didn't have an introduction by Bill Gates. This is probably the most recent version, I'm assuming. But the guy did write this book, which is Surely You're Joking, Mr. Feynman. And you should really read it, because it's fun as hell and it's not technical. It's just his experiences. So he does things like he's in the base where they have all of those experiments for nuclear and stuff like that. And he says, well, they had a safe. I wanted to see what's inside, so I cracked it. And he just says that, and he explains how he did it. So he explains all of these things. So trust me on this. For someone like me who was, I don't know, 14, 15 years old, and I wanted to understand how things worked, this guy actually explaining that you can be an adult and actually do all of these crazy things and act like a kid and actually do these things and get away with it. This is very nice. So feel free to read it. I do recommend it. But then again, this is not the intelligence level we expect from any of these sessions. The expected level will be something like this. Okay, yeah. So if you're familiar with the theme, you know what this means. Okay, you can't get any lower. Okay. So let's try to explain how things came along. So first of all, we are human, and more than animals, and even animals, they create some tools, right? So they have some of the animals use sticks, and they build like the dams, like the beavers. They build the dams, etc. So they understand how to use tools, right? So they understand how to do all of these things. But humans are expected to be a bit more. So over time, especially in the last 150 years, something like that, we've actually developed a lot of interesting things. So first of all, we started to count maybe 4,000 years ago, maybe more, and we use our fingers. So 1, 2, 3, 4, etc. So we did math with our fingers, right? So this seems obvious. Any small kid like 2 years old does this. And then we created one of those abacus things with the little balls, and we moved the balls and we did the math and things like that. Yeah, there's a limit to that, but if we have more abacuses in series, we can get more values, but there was a limit, of course. And then we created some mechanical machines. Some of them actually ran on steam, like a train and things like that. They actually had steam and ran them, but most of them, especially we still have things like telephones in up to the 90s, where this was mechanical switching. So when you dial the number in that rotating thing, it was still mechanical. So you think, oh, this was very long ago. Well, it was 20 years ago. Some things still existed like this 20 years ago, and they actually worked. They failed a lot because they were mechanical, but they actually worked. Now, obviously, we decided to create some electronic stuff because this makes much more sense, right? So we have more things that are not mechanical, they don't move, so they resist a lot better, except for the heat. But we know this, the computer burns up and then, you know, usual stuff. But apart from that, we worked with basic electronics and we created, you know, bits 0 and 1 and, you know, those ports like AND ports, OR ports and things like that, the basic stuff, right? And in the beginning, we used to use one of those valves that were with vacuum inside, and these burned out very quickly and things like that. So this was weird, but then they created the chip. And then from that point on, we had the actual machines with chips, and that became a whole revolution because from that point on, we started to have just small AND gates. And I still have computers from the 70s. I'm not that old. I got them from somewhere, okay? I wasn't even born at the time. I'm not that old, but we got some of those computers, and I look at that. Oh, this was very backwards in the days. This was very basic. Nowadays, you have a computer like this that has all of the power in the world. This is like a million times bigger than a computer that existed 25 years ago. A million times. It's not. It's not that little. It's actually quite a lot, right? And we decided to grow all of that because we have a lot of things like big data and things like that. We need to process all things, machine learning, etc. And there comes a time where these kind of computers reach a limit. So this computer, I have no idea, is probably 2 or 3 gigahertz in terms of CPU. The problem is physically we cannot go over this limit because there's, you know, heat and a lot of other situations that come along. So how do they fix this kind of problem? Well, they take the computers and they create things like pipelines in the computers where you run instructions in parallel and things like that. It's not as basic as a computer 30 years ago. This was fun, okay? But nowadays it's much more complex. And if you look inside the CPU, it's complex, okay? I'm not sure if any of you took electronics in university. I did. One of the jobs was to actually create a microprocessor. It wasn't easy, okay? And we had to study, at the time it was the Pentium, was it the Pentium or the 486, I can't remember, but we actually had to read the whole documentation to understand how it worked. It wasn't easy, okay? Now, when you work in IT, and especially if you are a programmer, you don't really want to care about such low-level things, right? You want to go higher level and do a print and then see things, right? That's easy, right? This is the way we want to do it. But here's the problem. 30 years ago, we had things like machine code, or if you want to call it assembly, which is the nice language that generates that machine code. It's one-to-one, so that's easy. But that is very basic language. And then you add some things, and then you are able to get this kind of thing. With quantum, this is exactly the same that's going to happen. So let's continue. Next up, and there is a reason why I add this specifically, because all the way up to the chips, this was very deterministic, right? So we knew what's going to happen. We feed things into the computer, and things are going to run. Well, with artificial intelligence and machine learning, things change. The rules change, right? Because the rules actually say that with machine learning, there is never 100% certainty. If you get 100% probability for something that happens in machine learning, that's the only option you have. You can't have anything else. Otherwise, it's going to be 99%, something like that, but it's never going to be 100. So there is a logic of uncertainty because of the way that they do trainings, etc. But this requires a lot more computational capacity because they try a lot of different combinations to run all of those things. But at the same time, you get much more nice insights. So you are able to do get some intelligence out of the data, right? Makes much more sense. However, it requires a lot of computation. Some examples for some companies might be just to take 1 or 2 hours to do a machine learning training, and then later on take that training and do predictions. But it's 1 hour might be okay with most data that small companies have. Very big companies like telecom companies, bigger companies than that, they'll probably take days, weeks, or even months to process all that data. And now you see where quantum makes sense, because there's a technical limit to all of the things that we can run in a normal machine. Yes, we have the cloud. I didn't add the cloud there because cloud is just using someone else's computers. So it's not a technological breakthrough. It's just an economical change, let's call it like that. It's not technical, right? It's just using the same computers, but someone else owns them and you rent them, so it's not really there. But how does this work? Well, with cloud computing, you just say, oh, I want the biggest machine, and if you go to Azure, you can actually bundle one machine with 36 terabytes of RAM. Okay, will that be enough? You don't want to see the price. If you want, just go to the virtual machines pricing, and it's somewhere at the very end, and you're going to have a lot of zeros in there. Okay, this is not going to be good per month, so a lot of zeros per month. And you have to agree to buy it for a whole year and things like that so that you can use it. Obviously, this is not viable for normal humans like us. Okay, so Quantum nowadays also exists in cloud formats. And that means that, yes, you can have your own quantum stuff, you know, devices and whatever you use to find all of the particles if you want to do that, but that's not viable as well. The best thing is to ask for someone like Microsoft or IBM or Google, AWS, something, that they can provide that service for you in a cloud scenario. So this is the same. I'm not sure you remember. I was going to say, do you remember this or that? No, you don't, because I don't either, and you look younger than me. But some time ago in the past, maybe 70s, 60s, there's going to be some big mainframes that occupy a whole room, and they would get some perforated cards that they would spend in a kind of typewriter thing, and then they would say, here's my program, feed it to the computer, and then give me the result in like sometimes in a paper, sometimes in another perforated thing, and they would put all of the programs in sequence from all of the people, and then you will get your result like the next day or something like that. Yeah, we've evolved past that, fortunately. Okay, please, any computer like this is a million times better than the whole room of here is still exactly the same. So if you need to run things, there's going to be a central location like a cloud. You can have your own equipment, but that seems very expensive. But you can have a cloud, and in a cheap way, you can run these kind of things. Now, how does this work? The problem is with quantum things, in terms of time, it's actually much faster, right? Because you have a limit of, let's say, 3 gigahertz, let's round the numbers. It can be more, of course, but let's round the numbers. And that has a limit. Let's say you run one instruction in sequence in the pipeline, that's going to be 3,000 million instructions per second. That's not the right number because there's a lot of clocking in each instruction and a lot of different things. But let's round the numbers to something like that. Well, with quantum, because the numbers are much, it's a number raised, like a 10 raised to the minus something, 18 something power. I don't know, it's a big number. A big in the sense of small, right? So that is actually giving us 1,000, 1 million times faster computing. But we cannot use the whole thing because obviously the atoms are very difficult to control, all of the particles are difficult to control. So we have to layer some things on top of this, and I have no idea how to do that, okay? Just I'm assuming this is done some way. You probably don't know how hard disks are done inside. There's some magnetic stuff, but how is it really done? Who cares? It works, right? This is our logic nowadays. SSDs, well, they have some chips inside, they work. We don't care. As long as they work, we don't care. So it's the same with quantum. As long as it works, we're not going to care. We just assume it works. If it doesn't work, we'll blame Microsoft or someone else. It's their fault, right? It's always like this. Now, as I mentioned, I really don't care how it is done as long as it works. Now, I want to explain some differences here. So when I mean traditional, I mean the normal computing that you have in a normal computing, like run a program, C#, Java, Visual Basic, whatever you want to run it, Python, if you are doing a lot of machine learning, anything you want. Anyway, you have bits. So bits are, you know, in a normal computer, you have registers. At a very low level, you have registers. Bits actually exist not as individual bits, but usually groups, and something called bytes, which convention tells us it's around 8 bits. But in the past, the number was different. There wasn't no formal definition. Nowadays, we just assume it's 8 bits, but technically it's octets, but no one cares. Anyway, bits and qubits. So what are qubits? Qubits, like the Q, actually refers to quantum. Makes sense, right? So if you want to keep things very, very simple in practical terms, you can just assume that a qubit has a value of 0 and 1. Okay, it has much more things because It doesn't really have the value of 0 or the value of 1. It has a probability of being 0 or being 1. It's like Schrodinger's cat, right? You know, the cat might be alive or dead, but everyone should know that 75 years later, the cat must be dead. Okay, it's obvious. I'm not sure how I did not win the Nobel Prize already, because I said to everyone, the cat's dead. But people still assume the cat might be alive. No, it's dead. There's no cat older than 20 years old. Anyway, as I was saying, there's some certainty in bits, but some uncertainty in qubits, especially because there's other things like entanglement between qubits and things like that, which make it, there's going to be a lot of probabilities, a lot of uncertainty, a lot of weird things that most of these you're not even going to care, because you're going to have a framework on top that just solves all that problem for you, at least. Okay, but in this case, same way as in a normal programming, that you want to understand what kind of things exist in the computer, like registers in the CPU and things like that. If you're doing assembly, you want to understand that those things exist, even if you compile like in C#, and then yes, there's going to be those registers. And unless you're doing some capture the flag or some hacking or something like that, you're not really going to care how they look, right? Because you're going to do higher level. But here, to understand how things are done, and especially if you want to do some optimization about some process, you want to save some time, so you want to know how these things actually work to make them faster, right? Anyway, so reading a qubit, and this is a problem that we have with Heisenberg's uncertainty principle and things like that. If you try to read the state of some particle, you will invalidate the particle. So you can see the position, you know, in typical Heisenberg thing, you can see the position or the speed, but you cannot see both. If you try to see one, you're not going to see the other one, so you can just statistically assume that they are somewhere. It's very weird, right? So it doesn't correspond to our human world where we see chairs and tables and things like that, and things look, you know, fixed. Yeah, you know, the chair's there. You know, there's a physics mathematical probability that if I go to that chair, I will actually pass through the chair. It's, you know, 0.0000000 something, but it is, because technically it is possible. Okay, but obviously if I go into a chair, common logic says that I'm going to get hurt, right? But technically it is possible, but we assume that that's not going to work, and it's the same with our typical bits in our computer. Okay, so anyway, weird stuff does happen, so that's true. But let's try to assume what are the things that are actually stable, because we know there's a lot of instability, and the same as a computer. So for instance, in the 80s, 70s, they came up with diskettes that were 8 inches, size, then 5, and then 3.5, and then you know, hard disks, and then bigger hard disks. Nowadays there are hard disks bigger than 10 terabytes, when at the time the same size in terms of density would only occupy a few kilobytes. So again, 1,000, a million, 1,000 million, growing bigger every time in the same amount of space. So we've evolved a lot. It's not just Moore's law. We've actually evolved much more than that. But with quantum, it's our next step to say, oh, we're going to cheat. We're going to go directly to those particles, and we're going to try to make it work. Is there going to be something faster than quantum? Well, you can optimize the way you read the particles, but they're always going to have some weird behavior. Temperature is going to affect it a lot. A lot of weird factors are going to affect it a lot. You know, things like dark matter. Does it exist? Does it not exist? Probably exists, but no one really knows, right? But if that affects something, is that visible here? Neutrinos and weird things like that. Do they exist? Well, they pass through our bodies. We don't know. Do they affect this kind of thing? We don't know. Okay. So the idea here is 30 years ago with this big diskettes, we just assumed that that density was good enough for us to have a good understanding that that thing was actually stable. Nowadays, we assume that 10 terabytes in a small disk are stable. But, you know, we've evolved. We've worked on the problem and we've evolved. So this one will evolve as well. Anything bigger than quantum, well, it's hard enough to see this one. So I'm assuming that in the next 50 years, probably not. But, you know, if we run into some aliens that tell us, oh, miracle solution, you have warp drive here we go, have fun. Store data in other dimensions. Stuff like that. Well, maybe there's a possibility, I don't know. But anyway, usages for this kind of thing. We can actually use AI and machine learning with quantum, so that's easy. Oh, sorry, this is wrongly done in the slide. So if you have AI and machine learning, there's the typical scenarios we know: driving a car automatically, doing training on actual data. So we have a normal data table that has stuff like client information, going to the supermarkets, knowing trends for people, checking out their YouTube usage, that kind of thing, giving us advertising, which is a parasite that we have to live with because they pay for, our social media and stuff like that. It's free because we are the product, but all of this exists in AI machine learning, but that's still slow. Can we make it faster for quantum? And the answer is yes. Obviously, we can make it faster, but we have to work from the ground up. We have to create all of the infrastructure from the qubits, in this case, all the way up to the higher level. Same as the other ones, no difference. And some of these things are actually being done. So there's going to be Q#, same as C#. There's going to be a quantum developer development kit and things like that. That also exists, and you can try it out. At the end of the session, I'm going to give you some links. One of them is like a 5-6 hour developer course for quantum that actually explains to you in very big detail how these things actually work. Okay, and this is the kind of thing that even if you want to try, it's actually the same as machine learning. I can be here. I've done a lot of sessions for machine learning, and the trick that I always do is I cannot run training live, the machine learning training live. I can train it before, one day before. I can leave it to run for a few hours, and then I can tell you exactly how to start it. And then I'm going to do like the cooking shows, which is we put it in the oven. Advertising now, wait 10 seconds, come back, and then suddenly, here's the cake already done. It only 10 seconds. How good? And it looks perfect because we tried this 20 times, and this one was the one that was okay while we were recording. And this is the same. So we can show you things, but not in real time because it takes more than 1 hour for obvious reasons. But anyway, if you use this just for quantum, and these are just a few examples. Let's try it out. So there's something called optimization, and optimization is just taking everyday problems like I don't know, health, cancer detection, anything related to machine learning, AI, etc. So the things that we already have, but using quantum to speed up finding things. And remember, the logic here, although yes, you can use the logic of bits, yes and no, and try to replicate an exact computer as the one you already have. In fact, you can also use some other optimizations which are available in qubits, some weirder operations. I'll try to show you one or two, but you can actually use some of those operations to optimize things that in a normal scenario you'd have some multiple operations to do in a computer. Okay, I'll show you one or two just for you to get an idea. But anyway, a lot of things like this can be used. Machine learning is probably going to be one of the biggest candidates because, let's say, on an everyday thing, you have your computer, you want to do math like a calculator, you're not going to use a quantum calculator. You're going to use a basic calculator that comes with Windows, right? You don't really need that. Use your fingers if you can, right? But the thing is, for processes that take longer and usually schedule them as a batch, this is a good example for quantum. Anything real time, I wouldn't recommend for one simple reason, because quantum, same as a machine learning related, it takes a bit of time to start, to prepare things, to prepare the hardware, to actually run things, to capture the results, and to actually show you the results. So it's not instant. That's a limitation. Okay, it's not a bad limitation because if you consider machine learning, it was going to take 2 months. Instead, it took 2 weeks. Yeah, that's fine. No problem. We're happy with this. Okay. There's also some pricing thing. I'm not going to go into details. I have no idea what the actual prices are, but in terms of optimization for costs, there's also some things where you should try to prepare all of your code, all of the things that you are doing, so that you don't waste that much computation, because it does require a lot of energy to run this kind of thing, etc. So there's going to be some cost. It's like running Bitcoin stuff, right? You know the cost for Bitcoin, right? So if you run things like the Visa network costs for a whole year, you would spend something like 1.5 suns. And when I mean sun, I mean the actual huge star that we see every day in the sky, right? You have to consume a whole star like that per year to actually 1.5 to actually run the Visa network. Okay, so that technology obviously is not optimized to run payments, normal everyday payments, right? Same here. There are some things that are optimized, some things which are probably not. We have to look at them. So a few more things to mention. Skynet doesn't count. Quantum cryptography. Well, yes, there's some scenarios where, I'll get to this later, but the idea here is that if normal cryptography, like public-private key cryptography, is already fairly secure, so you have different algorithms, but let's assume the most current ones, they are fairly secure, and they tell you, yes, it's going to take, 10,000 years to crack the thing. But because we rotate the values every year, this is all okay, so you're never going to get hacked unless you're really, really lucky. So that's fine, right? With quantum cryptography, you can go further, and you can expand that value to be literally impossible, because you can do quantum entanglements of particles and guarantee that if you try to read it, you can only read it from the same particle, etc. And there's also another thing, which is if you try to read some value along the way, let's say it's a transportation of a value in a quantum world, let's call it like that. If you try to read the value, that value becomes invalid. So even if you try to read it along the middle, you lose something, and in the end, someone else at the destination will see that they had something like the person in the middle or man in the middle attack that you had there. So it doesn't work as you work with optic fiber or normal cables and things like that. So it actually changes the state. So this is something that I mentioned before. Anytime you try to read values, the value of the state changes. There are some tricks to that. I'll show you one or two. Anyway, the last one is the cracking part. So if you have normal cryptography now, and because you have all of these powerful tools, those are going to be invalid, and you can crack some codes very quickly. This was the original intention of using quantum a long time ago, like NSA and things like that, to actually use big computation to crack this kind of things. Okay, so if you crack it, then you create some cryptography to solve your problem, and it's a cat and mouse kind of thing. Someone else will hack that other one as well, which is fine. This is going to work a lot. So this is all that's working. So anyway, all of these options are perfectly valid. No problems there. The options are endless. Yes, you can do a simple print, hello world, hello quantum world thing if you want to. Yeah, but that's not very useful. But technically, you can. Okay. So let's talk about bits very quickly. Everyone knows what a bit is, right? I'm assuming. So 3 possible values. So what's the 0, 1? I'm assuming both. And then there's a 3 state, which is the disconnected states. So it's not just zeros and ones. So suddenly we have a rule change. And in the quantum, you have a lot of these kind of rules. But the 3 state is you pull the cable. So this is normal in buses on the computer, because you disconnect the thing. You have a 3 state solution where you disconnect the cables from the bus, so it doesn't affect the things. This is actually one of the bases for modern computers. So technically, you actually have 3 states, but you consider 2 when you are doing programming, because it's more of a hardware thing. Anyway, these are electric tension measured in volts. Value 0 is usually from 0 to 0.7 volts. Value 1 is typically between 2 volts to 5 volts in the traditional, traditional bits and bytes since, I don't know, the 70s or even before, I don't know. Ever since I can remember, since I was born. In more recent times, some computers had 3.3 volts because this was low cost, low power, right? And then you had even more and even more getting lower. So 3.3, 2.2, and now even closer to 2. Anyone knows why you cannot get lower than 2? Well, you can a bit, but anyone knows why? Okay, you probably heard of LEDs, right? And LEDs usually have a value to turn on in which the power has to be 1.4, 1.7 volts to actually turn itself on, right? It's a limitation. It's a diode logic. So all the way up to 0.7, that's a reasonable limit where anyone in that range, we can assume it's a 0. From that value all the way up to 2, we can assume that there's some uncertainty. We're not really sure where it is, okay? So we don't want to risk it because it can be, we know it's going to be a 0 or 1 if you actually read it, but we are not 100% sure. So we always try to guarantee that values are always bigger, okay? And in the quantum part, the problem is the same logic, but applied to a completely different reality, right? So same logic as this, but different reality. Anyway, there's some lower values now to save some money, but logic is still the same. Remember that even for bits, it's only 99% guaranteed. So if you fiddle with the cable, even let's say for a computer, hard disk, okay, there's going to be a smart value that says hardware CRC error or something like that that shows up as an error. Usually says replace the cable because the cable might be faulty. In practical terms, if someone fiddled with it and shows up in the errors, yeah, don't touch it. That's the logic. But apart from that, the logic is please replace the cable. It might have some electrical problems, and then it will be fine. With electric cables in most computers, we assume this is not a problem. They have correction for most things. So even if there are errors, same as the internet, you send a packet out, and then if the packet is lost for some reason, it automatically sends you a new packet and things like that, so that you can, reconstruct the message if you lose a packet. Same here, but with quantum, it's an extreme level. Okay, anyway, so a normal computer will use some instruction sets. So we have machine codes, but let's call it assembly. And you have things like you have register 1, register 2, you have some values, let's say 32 bits, 64 bits, whatever, and you copy the value from register 2 to register 1. You can do addition, so you can get value of 10 and 4, register 4, all the way to register 3, and add to the actual value of register 3 as well. So 1 plus the integer plus the other value. Intel computers are typical for having a lot of these complex extras, which make it actually very slow. But that's fine. Multiplication, etc. But you didn't have multiplication before. 1,000 years ago, when we started with computers, multiplication didn't exist. You want multiplication, you create a function that's called multiplication. Add for each, and then add. So that was the multiplication. Okay. If you remember, probably heard of Turing machines, which is a very basic thing. You can construct all of these adds, moves, etc., just by moving a tape from front to back and things like that with very basic instructions. So this is what you can expect in quantum at the lowest level. Okay, not exactly that, but this kind of thing. So anyway, if you want to grow bigger, you have a machine, you create your own operating system, you create your own libraries so that you can grow things. So you have a library for multiplication, a library for powers, a library for, I don't know, something else on top, something else, factorial, I don't know. You grow on these kind of things, right? Makes sense, right? But anyway, with the higher programming languages, they will call that library that itself will have some function that calls the other function, and so on. This is what you need to expect with quantum. If you want to play around with something this small, you will not be able to recognize it. So what you actually do is you turn the small values, small instructions, into big ones by growing like this. This, in most cases, is already done. So you don't have to worry that much because most of this already exists. Things like I mentioned before, a simple hello world in a CPU world is about 100 instructions at least, right? So that's still going to be a lot. In the quantum world, probably a bit more, okay? But still equally as fast. Anyway, so far so good. Okay, so far this is not difficult, right? We're going to get to the most difficult part in a second, but so far is okay. Just making sure we have some time. Anyway, so qubits. So I'm going to show you some links here, and this is going to be for homework. This is going to be in the video, so you can have a look at some of this, but I will show you some of these pages. There's also an additional page that I stole from a different session, and I will show you towards the end, and that also has that link for the workshop, right? Anyway, let's keep it very simple. Let's keep it very nice, and let's try to make it work like this. So first of all, what is a qubit? So a qubit, and I've actually used the Wikipedia because the Wikipedia tends to explain some difficult things in a very easy way, and I like it. Okay, it's not perfect, but it works fairly well. So anyway, let's increase the size of this a bit. So qubits is basic unit of quantum information, blah, blah, blah. All this is very nice. How does this work? Well, let's assume that you have zeros and ones, but in the qubits, a qubit is actually a multi-dimensional thing that has a vector that points to a specific place, right? So if you have particles have spin, particles have polarities and things like that. which is weird, okay? So we don't really recognize that in a computer high-level world. But the reality is, let's say a particle is pointing up, that means that it's a 1. If it's pointing down, then it's a 0, or vice versa. You can use conventions for this kind of thing, but basically this is possible. So I actually considered making slides out of this, but going directly to this thing with the actual explanation, I think it's actually much easier. Plus, I would do a lot of work, and then it would not be as good as the one on Wikipedia here. So the example here is when you have a qubit, it looks something like this. So a 0 qubit, and they use these kind of things. They call them brackets, okay, bra-kets, and these are the vertical sign, the vertical pipe, and then the value, let's say 0 or 1 in this case, and then a greater than or less than symbol, like a indentation kind of symbol like that. Now, this is a vector. In this case, it's two positions. And if it is a 0, let's say that you have a 1 on the first dimension and a 0 on the second. If it is a 1, it's the other way around, okay? So there might be other values like 0, 0, 1, 1, etc. But let's ignore those values for now. We can use them if you want to in certain ways, but let's keep it simple. We just want 0s and 1s because that's what we as a human, well, a machine actually, but we as a human in the end understand as well, okay? So we have some other examples, okay? So an example of this one, which is 2 qubits here, you actually have 4 coming out. So you have 1, 0, and then all zeros, which is fine. So this is the convention that they typically have. So 0, 1 is going to be that one, the other one is going to be different. You know, you don't have to memorize this, just give you an idea how these things actually exist, okay? Anyway, there's a few states, so there, don't worry about all the weird letters, okay? But let's say that the value of this, okay, is actually a combination of 0s and 1s, because let's say you have a qubit, you don't really know if it's a 0 or 1. There was a probability of that being a 0 and a probability of that being a 1. Okay, so let's say you have 90% probability of that being a 1. That means it's 10% of being a 0. Makes sense. And because we are human, we assume that, you know, that's closer to the limit on that side. So that's probably going to be a 1. Okay, but in theory, it's never going to be 0 in any of these cases. Same as the particles you have on diskettes, right? So the mechanical particles, they also have like, let's say, horizontal and vertical, or, you know, 90 degrees turning the particles as well, so that they would return different magnetic values. But the logic here is exactly the same. Even if it wasn't 100% rotated, you could still detect that it is still the same thing. Actually, that was used to hack diskettes. So you could clean the diskette as much as you want. If you put it all to zeros, which is fine, or all to 1s, some of the values were exactly at 0, others were a bit higher. That means that they memorized that they had different values before, so you could hack it and figure out that that was the previous value. So yeah, this was very easy with diskettes, okay? Not rocket science, it's actually, the theory is actually very easy. The hardware to get that's a bit harder, because you have to be very precise and measure the thing. And then there's the logic of probabilities. And then if you clean it up very thoroughly, like 0s, 1s, 0s, 1s, that actually deletes the thing, but not that much. Anyway, they actually tell you that, well, it's not exactly 10%, 90%, it's actually multiplied square, and then is equal to 1, but the logic is fairly the same. Anyway, a few examples of how a qubit looks in what they call the bloch. Feels like a Klingon, doesn't it? A Bloch sphere representation. So basically, a qubit looks somewhere where you see that one, but it can point to different places, and then the operations you have something called logical gates, quantum gates in this case. They will put that value somewhere else. In, let's say, in this, we see 3 dimensions here, but this can be different. But they will put the value somewhere. Okay. So what I'm not going to show you math, so that's boring. Please don't. So some operations on qubits. Some of those are logic gates, and this is the one I wanted to show you. There's a few others like quantum measurement, etc. Let me just quickly mention the cryptography first before we go into logic gates. But the cryptography is actually simple. So we talked a bit about this. We can actually exchange keys. One of the biggest problems we had before was to exchange keys, right? So I'm going to connect to the other computer using HTTPS. and we exchange keys on the fly. So although, yes, this is done in a way that this is fairly secure, there's always a possibility that it's not 100% secure, because during the key exchange, if we monitor the actual key exchange, we have some added information that can help us crack things, okay? Some protocols anyway. And this actually solves problems. One of the things that exists, wait a minute, it's actually here somewhere, quantum entanglement. Here we go. So with quantum entanglement, I'm not going to go a lot into this, but the logic here, let's say you have 2 bits. So this, you have 2 bits, 2 qubits, one of zeros, and it can be zeros or it can be ones, right? So if you have 2 qubits, you give 2 qubits to 2 different people. They're going to share the same, if they are entangled, they're going to share the same value. So if you read the value on one side, the value on the other side is literally going to be the same. So this is actually very good for you to share some values that only these 2 people will know, no one else. Okay, so there's also other usages. For instance, one of the things you probably heard of is the entanglement of particles, where you can have a particle here, a particle on the other side of the world, and then they will update itself automatically. And this is good for data transfer. I'm not sure how they actually use this. I'm not sure if there's a practical application already for this, but the concept is this. And some people actually mentioned that this breaks the laws of physics because it goes over the speed of light. I'm not sure, but it seems interesting, okay? Seems like the kind of thing that powers a warp drive in the future, so I'm hopeful. Anyway, I want to visit a few other stars in a few years. Probably not. Anyway, there's some logic gates, so please don't be scared about all of the things that you are going to see now, but these are some of the symbols that you have some logic gates. And in a traditional bit style thing, you have ANDs, ORs, XORs, you know, the usual NOTs, etc. So you have all of these things, but here it's different. Remember one problem, which is if you read the qubits, they change the states because they make it uncertain. So that's going to be a relatively bad problem with this kind of technology. However, some of these gates are intelligent enough to leave in the qubits a true correct value. So they read them and they transform whatever, all of the qubits that they have to transform, but they still leave some values as expected. So you while reading them, you read them, but at the same time you guarantee that they are stable. Let's call it like that, right? So you can read them multiple times. Anyway, this looks very scary. Everyone took a linear algebra. I'm not going to ask questions, don't worry. But you know, like matrix and things like that, how these things kind of work, right? So you can apply, you have like a vector, and then you apply a matrix to it, and then you transport the vector into a different location. You transform the vector in some way, right? This is the same with qubits, okay? So anyway, just to mention a few gates. These are examples of a gate. For instance, this is a sum gate here, what they call a full adder. And this name here, I mentioned before, so Feynman, okay? So even if at the time it was theoretical, Feynman said a lot of things, about a lot of different things, but he've actually theorized some of these things. Now, for instance, an adder, if you remember a normal bits scenario, you have bit A, bit B, and these are zeros and ones. And then you have C, which is the sum. So if both of these are 1, the C is going to be 0 because you have an extra bit. Let's assume it's the last one. You have an extra bit, which is the carry, right? So that means 1, 0. So that means a value of decimal 2, right? And if either original bit is 1, one is 1, one is 0, then the result of the output, the S, is going to be 1, and the carry is going to be 0. If both of them are 0, everything's 0. The usual logic, right? This is exactly the same, just uses some different gates with some different logic, but in the end, the result is going to be similar in some cases. Some of these actually do the typical operations, but let's see a few examples. So a few examples. Identity gates, yeah, that's obvious, doesn't do it here. Some polygates, and they act on a single qubit. A typical scenario is the NOT, so inverting the bit, makes sense. A qubit makes very much sense. It's the basics of all logic to deny what is true, right? Anyway, square roots, etc. So with square roots, you're actually moving the bit around. Doesn't mean you change its states, But remember, let's say you are measuring the top part, the north pole and the south pole of that sphere as zeros and ones or vice versa, right? If you move it around someplace, there's still a probability, there's still zeros and ones, but they are in a different place. So they store different information. Do we need it? Probably not, but you know, you can do stuff with it, advanced stuff with it. What? I have no idea, but you can, okay? Anyway, some control gates, this becomes interesting here. So control gates with knots, so this becomes a bit more interesting because you start with two values, and the answer is here. You start with two values, A and B, down there, and that A and B is going to be the two original qubits. So if A is going to be 0, nothing changes. If A is going to be 1, that means you enable. It's what they call control, so you enable something. It's like ship select or something like that in a normal hardware, okay? So if the A in this case is equal to 1, in that case B stops being B and becomes the result of that operation, which is A XOR B, right? So if A is 1 or A is 0 or vice versa, it becomes, so if they're different, it becomes 1. If they're the same, it becomes 0, right? And the logic table is probably here somewhere. So yeah, logic table is probably here. So 0, 0 becomes 0, 0, 0, 1 becomes 0, 1, which no change, because the first original one, the controller bit is actually 0, and then 1, 1, so that means that if this is 1, they will change this one. So the idea here is that they will rotate these bits, and they will 0 becomes 1 and 1 becomes 0. That's just simple logic, okay? But anyway, then there's these values for probabilities and things like that. I'm not going to go into details because the value is not just zeros and ones, but you can actually use it. Anyway, a few others. So controlled phase shift, so you can do a lot of changes. When it says controlled, as I mentioned, there's always a bit that says on or off. So if it's off, you don't do any operation. If it's on, you do something, right? It's practical in the hardware even for this. Some rotation, so you rotate the vector somewhere. This one is especially interesting for a lot of applications, machine learning, cryptography, etc., which is the Hadamard gates. And what actually happens is that they apply some mathematics to the vector, and the result of this is going to be, let's say you have a value. So that value becomes with equal probability of being 0 or 1. So you basically have a randomizer, okay, which can be useful. You get a random number. So this is one of the first examples you usually have when you have, a computer, and the first thing, oh, you have the rand option. Let's generate random numbers. Well, you can do it here as well. A lot of applications for this. True randomness, this is not the same as pseudo-random computer thing that you can predict. This is really random, so it's very practical to use. Swap is swap, so we swap the values between the two, and then some other gates like this one, if I'm not mistaken, this one, only if this is on, they will do, was it an XOR or not? Can't remember, but it's still based on the first one, and then the output changes. So in this case, they only change if this one is the same as the input, but the output, this actually changes. It's an XOR as far as I can tell. Okay, but it's not, you'll have these kind of things. And remember, from an XOR, from a NOT and things like that, you can actually construct simple ANDs and ORs and those kinds of gates that we use the most. However, most compilers will know that this is not required. Anyway, I just wanted to show you a few examples. So this is in the list of links, and this is quantum computing here. So you have some quick starts. And yes, you can go to the Azure portal and then create a quantum-based random number like this generator. So to do this in the Azure portal, so that's simple. First of all, you get a free Azure account. You go to azure.com/free. You try to get an Azure account for free, and that's free for a whole month with some credits and things like that. And then you go to this, which is the Azure portal. It might look different from different people. No one else has this kind of colors. I personalize things, a different word to say hacking. Anyway, you can just click here and say quantum, and then I actually create the probably Azure quantum. Give me a second. Azure quantum. You can be more specific. And then all you have to do is to say create, and then you just give it some information. So the subscription is how you pay for it. The resource group is just an organizational location where you put it. And then name, give it some name. Around the world, this is limited, so only about 10 regions out of the 60 or 70 regions of Azure currently have this kind of thing for trying. But you can try it out, some storage account, etc., and it creates your quantum workspace. Now, the quantum workspace, let's just say that you can actually play around with hardware, okay, if you want to, okay. And to do that, you have some providers here. By the way, the example I'm going to show you in a few seconds actually has this option for you to submit a job. So that's the option there for job management, okay? But I won't go into details for this. This will just take too long. But for these providers here, you can actually have the Microsoft QIO provider, which is the quantum inspired. This is the actual name, quantum inspired optimization. So you can run this, and then they have some options here using FPGAs, using a lot of different things, CPU, etc., etc. So there's going to be a lot here, but you have other providers, and these are external providers to Azure. That the free account doesn't work; you have to actually pay for it. And you have things like Honeywell, IonQ, and things like that, where you can just say add, and then you have the possibility of pay as you go, but then you will have to pay for some value. Starting price is 0, but then you'll have some pricing to run this in the actual hardware, right? But you can always run this in a simulator on your computer, so that's fine. Visual Studio Code is your friend. You can do it all there. It takes much longer, of course, but you can try it out. By the way, some things, like if you have like 100 qubits, that's going to take longer than your lifetime, okay? If you want to do the processing, mix all of the processing together in your computer, you need to use quantum for that, because if you are trying 1 or 2, that's microseconds, it's fast. If you mix a lot of them together at the same time, that's going to take a lot of time. So to simulate them is not a good idea. You have to run them in hardware, okay? But for small things, you can try in software. You try them out, you build libraries on top of that, and then once you test everything out, but in small chunks, you submit to an actual job, so job management, you submit the job. It's like 2 lines of code, so that's easy, right? And you submit the job, and that thing actually runs. So there's more. I don't want to show the other provider because that's much more expensive. That's a lot of zeros there. But anyway, just give you an example of a Q-sharp example. So please ignore most of the things there. The part that I want to show you is, so there's an operation here, and you have a parameter number of qubits that you want to play with. And here you just create some qubits, an array of qubits based on the number of qubits that you want in total, okay? And then you say apply to each of the values inside of that register, all of those qubits. You apply the this one that you probably remember. Wait a minute, oh, logic gate here, wait a minute, okay. So you apply this one, the Hadamard gate, Hadamard or Hadamard, I don't know. I'm not sure if the guy is French. I didn't ask. But anyway, you apply it, so you basically get random numbers here, and then you return the values, of course. But then you can say simulate, which actually runs this with those qubits, and you say that the parameter is to run that function with those 3 qubits. But then you can say that you can connect with Azure in some subscriptions to the actual hardware, and then submit that by saying, oh, I want to use the simulator. So this can be a simulator, or I'm assuming in the future hardware will be available in a very easy way. But so far, most of these are simulators. But then you can just say submit, and then that runs asynchronously, and your result is available for you anytime you want to find it. So if you say status, at some point in time, it's going to say completed, and then you go there and get the information. And this is the result. The output is going to be the result of this. So that's going to be random numbers, zeros and ones. It's not an actual number, it's bits, right? So it's a qubit. So it's 3 qubits, zeros and ones, completely random. And you get those kind of values, which actually make sense. There is more information here, but I'm not going to go into the details. Just to mention, the quantum Azure Quantum documentation here, and then I'll show you the links. So basically, you have a lot of quick starts, tutorials, etc. Just try these out because they have code that looks like this. And code that looks like this makes much more sense than the stuff that we saw on Wikipedia, right? Because that's strange, etc. The logic here is try to understand how these gates actually work, because these are actually important for you to be able to program those things. And then to program those gates is just to say, apply to each, and then something, or something as simple as this, okay? But you're gonna have some libraries that build on top of other libraries to do high-level functions at some point in the future that actually apply. For instance, you already have things for machine learning. I think TensorFlow and things like that you already have for those kind of things. If you wanna spend money on quantum and actually run it, that should run okay. When I mean this in a kind of negative way, just for one reason. It's not fully tested yet, so there is no 100% guarantee that this is going to be perfect, but I'm assuming that in most cases this will actually work, okay? Anyway, let's show you a few other links as well. So these are the links that I've tried to show you at some point. The most important ones is probably going to be the Microsoft.com Azure Quantum. That's going to be your starting point, and then you have a lot of tutorials for all of the things you have available. You also have a few other things, but that's on a slide that I've actually stolen, but I left the name of the person. So this is from a session that existed in January in Global AI Bootcamp in Singapore, and I've actually copied this from that session. The speaker's name is there, so I'm not actually saying anything. If you want to see the session, you are more than welcome. It talks about completely different things that we are talking about now, more use cases, etc. But still a very interesting session. What I wanted to show you here is you have the Azure Quantum Developer workshop that you can see. That's interesting, 5-6 hours kind of thing. But then you have some other links which are repeated from mine, but you have more like open source libraries, etc. Some libraries where you can do quantum with. Okay, so that's actually going to be fun. Okay, and remember, you don't have to actually pay for things, the actual hardware. You can try this out in simulator in your computer. If you try out some of these examples, if you try one of these quick starts that you have there, actually this one. So this quick starts here, Azure Quantum Portal, create a random number. I'm just going to show you this very quickly. So prerequisite, install QDK for Visual Studio Code extension, search on extensions, Quantum, as long as it says Microsoft Quantum, blah, 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 that's the one. And then you install a few other things, and then just follow this very easy way, and then you can just submit the jobs by running 1 or 2 lines of code. They actually explain what those lines of code are here. This is the random bit generator again, so nothing much, but then you can see exactly the code that you need to use to run it. Very simple, okay? Anyway, so the links will be in the video in any case, should be live anyway. And for me, this is almost the end. So, any guess? Is it up or down? Is the cat going up or going down?
No, this one is up.
No, it's actually down. It's actually down. You can see from the sides where they have the extensions to the staircases. Plus, there's going to be this extension outwards that you have for the steps.
Yeah.
So it's actually going down. But it is complicated because it's a matter of vision. So anyway, this is my last slide. I really want to thank you for being here. Everyone, you didn't run, so that's good enough. Okay, and I want to thank everyone here and also remotely for being here. Hope to get in touch with all of you soon. And yeah, thank you very much, and let's do lunch. Okay, thank you very much, everyone. Okay. Thank you very much, everyone at home as well. And Stefka, thank you as well. Okay, let's go get some food.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Data is super valuable asset in today's business. Data-driven decisions means 23 times more success in attracting customers, improving the bottom line, and future-proofing the company. We understand your data, your business goals, and connects it to time-proven and disruptive technologies, solving your pains. Welcome to the world of digital transformation. Data are the very heart of your company, and we provide you the best option for collection, storage, and analysis of your data, providing you with real-time insight and data decision-making. Seamless flow of data enables data-driven organization and is the basis for data democratization. We future-proof your company, leveraging data to extract the optimal value. Digital transformation requires all types of data you probably have. We gain insight into them with cutting-edge artificial intelligence and machine learning technologies. Artificial intelligence and machine learning bring data game on a new level, increasing exponentially the level of accuracy and prediction. Result: end of low-value repetitive tasks. We provide you with end-to-end solution stemming from your business goals and leveraging data to understand and sell to your customer by delivering campaigns, marketing strategy, and UX UI. One-stop partner, global presence, data and AI-driven, marrying the best of business, technologies, and creative. Digital transformation with Adestra is your path towards data-driven future.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
DataArt is a global software engineering firm with a uniquely human approach to solving problems. We have teams of highly trained engineers with over 20 years of experience. Everyone upholds a deep understanding of the industry sector through ongoing technology research. People first. Relationships are the foundation of long-term value generation. We hire people for the long haul. Projects change, but our employees remain with us. Commitment to people is the main and absolute value for DataArt. DataArt doesn't have a rigid hierarchy with a single leader. The flat and decentralized organizational structure is beneficial to DataArt's flexibility. DataArt's organizational structure is based around projects. We enjoy flexible schedules, vacations, and work locations, both at different developmental sales incentives, or from home. DataArt is built around people who want to earn a living using their professional skills and talents with minimal limitations on their personal freedom. A lot of people are happy to work for DataArt and stay with us for many years. They have the opportunity to learn, gain experience, and grow. Join DataArt.
Hold up.
Saturday Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
Data is super valuable asset in today's business. Data-driven decisions means 23 times more success in attracting customers, improving the bottom line, and future-proofing the company. We understand your data, your business goals, and connects it to time-proven and disruptive technologies, solving your pains. Welcome to the world of digital transformation. Data are the very heart of your company, and we provide you the best option for collection, storage, and analysis of your data, providing you with real-time insight and data decision-making. Seamless flow of data enables data-driven organization and is the basis for data democratization. We future-proof your company, leveraging data to extract the optimal value. Digital transformation requires all types of data you probably have. We gain insight into them with cutting-edge artificial intelligence and machine learning technologies. Artificial intelligence and machine learning bring data game on a new level, increasing exponentially the level of accuracy and prediction. Result: end of low-value, repetitive tasks. We provide you with end-to-end solution stemming from your business goals and leveraging data to understand and sell to your customer by delivering campaigns, marketing strategy, and UX UI. One-stop partner, global presence, data and AI-driven, marrying the best of business, technologies, and creative. Digital transformation with Adestra is your path towards data-driven future.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
DataArt is a global software engineering firm with a uniquely human approach to solving problems. We have teams of highly trained engineers with over 20 years of experience. Everyone upholds a deep understanding of the industry sector through ongoing technology research. People first. Relationships are the foundation of long-term value generation. We hire people for the long haul. Projects change, but our employees remain with us. Commitment to people is the main and absolute value for DataArt. DataArt doesn't have a rigid hierarchy with a single leader. The flat and decentralized organizational structure is beneficial to DataArt's flexibility. DataArt's organizational structure is based around projects. We enjoy flexible schedules, vacations, and work locations, both at different developmental sales and centers, or from home. DataArt is built around people who want to earn a living using their professional skills and talents with minimal limitations on their personal freedom. A lot of people are happy to work for DataArt and stay with us for many years. They have the opportunity to learn, gain experience, and grow. Join DataArt.
Saturday Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
Data is super valuable asset in today's business. Data-driven decisions means 23 times more success in attracting customers, improving the bottom line, and future-proofing the company. We understand your data, your business goals, and connects it to time-proven and disruptive technologies, solving your pains. Welcome to the world of digital transformation. Data are the very heart of your company, and we provide you the best option for collection, storage, and analysis of your data, providing you with real-time insight and data decision-making. Seamless flow of data enables data-driven organization and is the basis for data democratization. We future-proof your company, leveraging data to extract the optimal value. Digital transformation requires all types of data you probably have. We gain insight into them with cutting-edge artificial intelligence and machine learning technologies. Artificial intelligence and machine learning bring data game on a new level, increasing exponentially the level of accuracy and prediction. Result: end of low-value, repetitive tasks. We provide you with end-to-end solution stemming from your business goals and leveraging data to understand and sell to your customer by delivering campaigns, marketing strategy, and UX UI. One-stop partner, global presence, data and AI-driven, marrying the best of business, technologies, and creative. Digital transformation with Adestra is your path towards data-driven future.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
DataArt is a global software engineering firm with a uniquely human approach to solving problems. We have teams of highly trained engineers with over 20 years of experience. Everyone upholds a deep understanding of the industry sector through ongoing technology research. People first. Relationships are the foundation of long-term value generation. We hire people for the long haul. Projects change, but our employees remain with us. Commitment to people is the main and absolute value for DataArt. DataArt doesn't have a rigid hierarchy with a single leader. The flat and decentralized organizational structure is beneficial to DataArt's flexibility. DataArt's organizational structure is based around projects. We enjoy flexible schedules, vacations, and work locations. both at different developmental sales incentives, or from home. Data art is built around people who want to earn a living using their professional skills and talents with minimal limitations on their personal freedom. A lot of people are happy to work for data art and stay with us for many years. They have the opportunity to learn, gain experience, and grow. Join data art.
Hold up.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Data is super valuable asset in today's business. Data-driven decisions means 23 times more success in attracting customers, improving the bottom line, and future-proofing the company. We understand your data, your business goals, and connects it to time-proven and disruptive technologies, solving your pains. Welcome to the world of digital transformation. Data are the very heart of your company, and we provide you the best option for collection, storage, and analysis of your data, providing you with real-time insight and data decision-making. Seamless flow of data enables data-driven organization and is the basis for data democratization. We future-proof your company, leveraging data to extract the optimal value. Digital transformation requires all types of data you probably have. We gain insight into them with cutting-edge artificial intelligence and machine learning technologies. Artificial intelligence and machine learning bring data game on a new level, increasing exponentially the level of accuracy and prediction. Result? End of low-value, repetitive tasks. We provide you with end-to-end solution stemming from your business goals and leveraging data to understand and sell to your customer by delivering campaigns, marketing strategy, and UX UI. One-stop partner, global presence, data and AI-driven, marrying the best of business, technologies, and creative. Digital transformation with Adestra is your path towards data-driven future.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
DataArt is a global software engineering firm with a uniquely human approach to solving problems. We have teams of highly trained engineers with over 20 years of experience. Everyone upholds a deep understanding of the industry sector through ongoing technology research. People first. Relationships are the foundation of long-term value generation. We hire people for the long haul. Projects change, but our employees remain with us. Commitment to people is the main and absolute value for DataArt. DataArt doesn't have a rigid hierarchy with a single leader. The flat and decentralized organizational structure is beneficial to DataArt's flexibility. DataArt's organizational structure is based around projects. We enjoy flexible schedules, vacations, and work locations, both at different developmental sales and centers, or from home. DataArt is built around people who want to earn a living using their professional skills and talents with minimal limitations on their personal freedom. A lot of people are happy to work for DataArt and stay with us for many years. They have the opportunity to learn, gain experience, and grow. Join DataArt.
I think that we can see you and hear you already, so we can start.
So we can start. Let me get to the presentation because now. Are you flattered? No, I got slimmer, unfortunately.
What a beginning of session.
Yeah. It was deliberate. I was fatter than that. In fact, do not call me fat. I was more prominent before, especially looking from that side, sideways. Now I'm. So you tell me when to start. Okay, so I want to just say that I'm Katalin Georgiou and I'm not fatter as before. So
we just started watching this, they have no idea what we're talking about.
True, but it was a discussion from the audience, which is, still waiting to come from the lunch to get the dessert. Why the dessert? Okay, so unfortunately, you which are seeing me on the camera, you have a very, very bad day. I apologize because you get no chocolates. And also, the session will be interactive and it isn't the best experience. But first, to ensure that I won't look that fat on the screen. So, before we take the sponsors, let's give Stefka chocolate. I want to look slim and I want to look like Superman. To continue with organizative and administrative matters, if you are not insured against the chocolate hitting you, please come forward because I cannot move that much because of the cameras. Otherwise, it's on your own risk. We have here a disclaimer. We do not recognize any injuries due chocolates. I'm Katalin Georgiou. I'm coming from Romania, the neighbors up there. Yes, we know all the jokes, Romanians and Bulgarians and Romanians. This time I won't say that Romanians are lazy because you know all this already. And this presentation will show you some way of, let's say, being lazy and getting results.
Okay, fine.
So, to know what to expect, if you know Power BI and you are an expert, okay, it's a presentation for you because it will show you how to marry with the IoT fast. It's not for specialists in IoT and specialists in Power BI. If you, let's say, are on the learning curve on one of these, you'll get something out of it, especially people who are learning IoT. I have to say, well, I'm always working in IoT. I like competition because I'm the best. And I'm modest, you know. So, getting things right. Let's click someplace. Yeah, that's that. Let's give a big thanks to our sponsors. Also, some of them are hiring because without them, I won't get that fat. Because you know, it's a big deal to organize a conference. And also, thanks organizers. And say hi to Misha, to Stefka, which is supporting this presentation, to all the people who make this possible. Also, I like coming to Bulgaria. It's a very nice place. And also, please do remember that Plovdiv, if you are looking from an exotic country, was European capital of culture, I believe, last year. So it's a nice place. You should make a visit. And always, you can claim expenses because you come to Data Saturday. So something like this. Okay. Moving forward. Yes, I'm not as fat as before. This is my opinion, but I'm still fat. I'm calling preeminent. Why I'm doing this presentation? Because I'm hungry. Okay, one. Second, what are my credentials? What makes me, let's say, qualified to tell you something about it? At work, we are doing IoT for a long time, even before IoT had a name. Also, we are Romanians, we are lazy, we try to do stuff on the easier way or simpler way or something like this. About continuing the credentials, from 2011, Microsoft awarded me each year the title of Most Valuable Professional. My current categories are, of course, no data platform. It's Azure and Windows development. I'm one of the doubles. Also, I'm a Microsoft certified trainer, and also Intel awarded me the title of Intel Software Innovator. That's enough about me. You see, it's a lot of me. I can talk a lot. Also, you should know that I'm not great on doing slides. As presentation goes, pretty much this is it, and we go back to the sponsors. Now I'm gonna start our journey in trying to marry Power BI and IoT solutions. It's a journey. I'm trying to show you different ways of doing it, from, let's say, tad more complex to that this way. That would be to simpler, but with some hitch. Okay, I will show you the limitation. I will also show you how Microsoft killed part of this presentation last week or something. And for this, I will need to, okay. First, I need to get rid of the chocolates. How many of you are familiar with IoT? Okay, so, I said I'm not good.
You get go.
So, are you familiar with IoT in Azure? Or just to start the story from, my question is, I start the story from Adam and Eve or from Adolf and Eve? From which one? Adam and Eve or Adolf and Eve? Okay, let's start from Adam and Eve. Also, I was gonna look time to time to my phone. On my phone, I have a timeline to show me where I am on the presentation. Okay, starting from the very, very beginning. What's the problem with the IoT solution? The problem with the IoT solution is the ingestion of data. Ask yourself, what? Okay, why is this a problem? Because sometimes in IoT solution, we have huge amount of data suddenly. And a normal solution that you engineer normally, it's not well suited by default if you do not think beforehand, sorry, to ingest this kind of data. Some people from Microsoft define this when we talk like a consumer-induced data store. Okay, let me explain how this stuff will go. For example, we have a solution in the shop floor, which is monitoring the machines. Usually, there are a couple of, let's say, tens of messages per minute. But something happens to a machine. The machine is stopping because has no raw materials or something. The next machine stops in the next minute. And so on to the entire shop floor. You are going from tens of messages per minute to thousands or hundreds of thousands messages per minute. You should not lose any of them. Why? On the shop floor, first you are talking regulatory concerns. I've seen, and that was an experience that marked me for life, robot arm hitting a wall. You know, we hit all the floor. We beat everybody on the floor. So this kind of machine can kill people, can maim, you lose production, a lot of stuff. And second, there are operations which are in pairs. For example, I open, let's say, a press, and I close it. If I lose a message, I will be under the impression that the press is open, for example, which is closed. And that's a problem. A normal solution, usually, it's calibrated for normal functioning. In these cases, you you'll have problem not losing data. So we are going now to the cloud. IoT as a concept is cloud, but okay. Okay, thank you. I'm looking big. The previous speaker.
Looking perfect, don't.
Yeah. I'm fluffy like my cat, which is okay. Sorry for the comic relief. Getting back, treating Azure like an operating system. It's an asynchronous operating system. It's based on queue and events. So it means that he is very well suited of absorbing this kind of data because he has a lot of requests, can fill the queue, and afterwards can process it. I said that we do not, it's not always a requirement to process all the stuff fast. It's just a requirement to get the data and not lose it. So essentially this requirement, it's fulfilled. And in, let's say, in Microsoft world, like on Azure, it's more than one way to skin the cat. But the recommended one, it's to use the IoT Hub. What's IoT? In fact, let's get, anybody's familiar with even have an IoT Hub, which are the differences? Yes, tell us. Please, Andre, tell us.
Okay, simplest term. Can that be heard from here?
You should be louder. Or
you should be loud. Or get here. You are fat enough.
Okay. So IoT hubs, two-directional communication. Event hubs, one-directional communication. IoT hubs, you have authentication per device. Event hubs, not so much.
Yes.
Thank you for the chocolate.
Always. Also, there is as big directional communication. What this means? That means that we have two queues. For each device, we have two queues. One for in, one for out. Also, most important, it's that we have support for device leads. But for this, Misha is the expert around. He will do a presentation eventually around here on device twins and all the topics. Okay, yes, we get the data somehow at the door of the Azure cloud. And next, we have the data on the Azure cloud. What to do next? Well, we need to move it around. What will be the simplest solution of doing it? Microsoft said that we should use stream analytics. Stream analytics is, okay, I will use an old analogy, but I'm an old fat fart. It's something like a telephonic switchboard. Depending on the data, based on the SQL-like query, I can send the data someplace. Okay, what this means? For example, the simplest example on Microsoft Help when they launched it, it was that if your credit card number is used in less than 20 minutes, at a distance more than 20 kilometers, send the data to this event hub. Otherwise, all the data should be recorded to this SQL database. And you can do this wonderfully with an SQL query. No big deal. Okay, this is absolutely wonderful. I talked a lot. And you ask yourself, I'm going home. How should I do that? I need to buy devices. Yes. Yes, of course. I need to have devices. My wife won't let me. My boss won't let me do it. So I'll try now because I will try now to share my screen and show you how you do it without spending a lot. Let's go back here and stop screen sharing, and let's screen something here, share. And let's see what we have live live. So we all are looking now what is shared. Yeah, I was able to do it, and let's try to also to change the sharing on the screen. just a second, to do a duplicate to the people in the room to see. Wonderful. Because I was using extended. So, through the help, let's for the support. Sorry, I told you to be in the first rows.
I'll learn you to shoot.
Yeah. I need to practice. So, how to start easily? There is something on the GitHub or a website, which is called Raspberry Pi Simulator, online simulator. The code, yes, you can run it physically. I replicated the hardware, I replicated the code. I done the code even this manner, which is a very strange manner. It's running Arduino code on Raspberry Pi, whatever. I've done it in C++, I've done it in C#, whatever, on Raspbian, on IoT, how it's called the Windows IoT. It works. And okay, moving forward. Now I'll get back into my chair and to try to show. This is my Azure portal I've created a long time ago. Some stuff. I created here an symptoms. I've created an IoT hub. So here I need to take the connection string. Again, if you're working with real devices, this is not the way to. It's trusted platform. You have some other ways to do it. And also, I'll do something very ugly. I will take the most powerful connection string and put it into this code. So, Shift and that's that. This is the only stuff that you can change in this online simulator. Yeah, you can play with the rest of the code. I'm not sure if you are able to delete it. And if you are able to delete it, okay. It just said that does not compile, but if you change it, will not change. You just, only this part you can change, really. And now we click run. Okay, something is there. Yeah, this is the most common error everybody does. Now I have copied not the device connection string, but the IoT connection string, which is used for administration. So I need to go here at the IoT devices, which are already created device. Let's say simulated P, and get from here the connection string. Again, it was a fortuitous error because this is something that you can that can happen in the real life more often, and you wonder yourself, yes, I copied the right one, and I copy a connection string, and why it's not working? Yet again, sample stop, run. So that will start sending stuff, and it's sending stuff. Okay, so we are doing the first step. The second step will be, let's go next on this way. We're going back to the dashboard because I make some order. We need to go to Stream Analytics. Stream Analytics, how it works. I have an input and I can have more one or more outputs. Here, as Stream Analytics go, it has an it's one of the Azure enigmas. You do not know how much you pay for it, because you pay if you create an object, and also you pay when you run it. But that's another topic. Let's look at the query. Okay, so here we have a very complex query, and we'll let's see if it's the right one. Yes, the right one. So we're gonna change it. We will do absolutely. Let me show you easily. And get rid and read of the stuff. Let's have something like this. So in fact, here you see that I can have multiple queries. In fact, even simpler, we can delete all the rest and we remain only to this. So what is doing? Unfortunately, here they are using the syntax like in LINQ. It's not select star from, it's select into from, whatever, but still it's there. So we'll save the query, and we'll start the job. This will take some time. Let's get it back to it and start it, and see what's happening. Also, at the end, we'll have some. I've created before already. Let me find it. Some from the previous data. It's created this. This has updated. You see, it's updated quite a long time ago, but the interface has updated because I updated all the workspaces. So still, here we see everything and anything. Yes, wonderful. Later. So sometimes new. That would be the report. Theoretically, after some times, you will start seeing the data. You see, the last time I ran really this demo, and let's see what's happening here. Not here. This is running, and if you are looking on the overview, it does not have anything out of the ordinary. Okay, so it seems the emulator is, maybe I deleted something from it, and it's I will just reload it. So we reload it, we change the shift end, and start it again. And now we'll see what's happening. And now it seems that it works okay, more or less. Here, we'll start seeing in the Power BI data in some time. But as you have seen, this process was pretty laborious. So we needed some steps to get here. Okay, to explain a bit this demo, what is doing. This is a real Bosch sensor for humidity and temperature. And when the temperature is above 20 degrees, blinks the LED. And this is all sent to the cloud. And now let us look a bit of data if we have it. So on the overview, you should see some data. Okay, it takes some time to get the data in. And this is a common problem with the cloud. Okay, still, this was a laborious approach to the problem. And now we are starting asking ourselves, okay, my boss wants to. This is my good part. So my boss wants us to create a solution, and we do not want to spend a lot of time. I do not have the time, I do not have the knowledge. What should I do? Okay, as interesting as it goes, Microsoft feel that problem. So I created something. It wasn't the only thing. Something called IoT Central. IoT Central, it's 1, 2, 3 clicks IoT solution. It's quite fast to develop stuff, but they have most of the control. So rest of the presentation will be around how we use I believe that here is not democracy. We have a camera which is going up and down. So, how do you, now we're starting seeing data, if you see here. You're having 20 messages. It starts with them. How we get together IoT Central and Power BI. First, there are a couple of questions. Let me show you a bit what is IoT Central. First, if you ask yourself if you need Power BI. Yes, I would say that you need Power BI because, okay, I hope that, yes, this presentation is recorded. And that is a joke, it's a bit of color. I said that Power BI, it's an orgasmotron for plant managers. They love to see on their iPhones dashboard from production. This is why it should be an idea to integrate Power BI. Second, how should do it as simple as it goes? Yes, sometimes we are paid by hour, but I'm still lazy. I rather said, so I will show you several ways of doing it. And I will show you that it was one simpler way that it's no longer available. And I suppose that Microsoft will get back. But first, get you around the bit IoT Center. So what's that? We create an application. And here, what we have. We do not create a gateway device. We create a simple empty solution. You have also templates for logistics solution for a lot of stuff. And you create a device template. Let's create a new one. Just for the example, also because we have time. So also, some of the device templates are already created for real device. So let's create one somehow. Believe that, hope that it's a double click, create new. It's not an OK button someplace. Okay. Yeah, let's click again. Yeah. Of course, that I have some, you see, was hiding the button. So let's give it a name. Let's give it a test. And let's do review. It's okay. IoT devices test. Let's move this. First, you can import a model, or you can create a custom model. To understand what's a model, first, it's the capabilities. What's the capabilities? They are the type of data. Let's say simple temperature or something. And it's a telemetry. It's data from the device, and I can say that it's the temperature type. Also, you can do a property or a command. Property will be something that you have in cloud. For example, the position of an IoT device. Nothing out of the, but the position, it's not coming from the device, you set it up from the portal. Okay. And command goes, let's try it. Let's say on off. You need to define what's in the command. Or let's try as property. You need you have a lot of stuff to set up. And also here at the semantic type, you can have it, let's say, telemetry, and we can have state. At state, you define what you want. You can say that this is an integer, and the value, let's say, unit, we add. We'll say that on, it's 1, and off, it's 0. Okay, wonderful. Absolutely boring for a database developer. Still, sometimes you can import from the real database model and stuff like this. But not dwelling into it. The interesting part, and I'm not going to show you here, I'm going to show you to the model I've created before, not device group. Okay, discarded, but still, I want to get device templates to this one. Is that you have these kind of views. You can create a view. Remember, this is a device group. So here I can put another one. Let's put a pie chart of some sort. And add style, add this style. And here we can say, I want to show in, I've created this device template to look somehow like the demo before. It sends humidity, temperature, and LED to show me the humidity. And this I update. Do not get fooled by this. This is not Power BI. So we can save this. This is a device template. So this device template, simulated device that they create. So we'll get back if you put publish. Well, first we need to publish it. And then I hope that sometimes, because this is transitioning between version 2 and version 3, sometimes they give you a small error. This is implemented now. If you have a real device, you need to implement this on the real device to send this kind of data to understand this kind of comments. And or you can have a simulator. They create for you a simulator. And what's interesting now, at V3, you have, if you define a device template, you always have also the graphicons. Let's see how it works. So this is the raw data. This is what they sent. You see that even now it's working. It's the right time. And, okay. So you see the data coming from the device. And, okay, we can do a drop marker. And before, you did these graphicons when you created a new dashboard. So here you added a device, here you put graphicons for each. Now it's a device template. Okay, getting back to the, now we'll do it on the worst way possible, getting the devices. Okay, so getting to this, showing. Also this you can put on the dashboard, but automatically from the device template, you have this kind of tiles for each device. Also, you can have graphicons and you can have a lot of stuff. Okay, I'm telling you that this, it's not Power BI, but still it's good enough for some scenarios. Okay, also you can have a tile, if you remembered. You can have a tile on which you put Power BI or a link of some sort. So now it's going to same report, the one like previous. And now we are in August somehow. So this is the data from today, for example. But what data is showing this? Also, we can have all this portal into one tile. What is the data showing this? Is data from where? Okay, the options are, is data from the simulated device from the IoT Central or the data from the Raspberry Pi emulator? Let me take out the bag because I'm even though I'm very gracious to look, staying like this, I'm even gracious. So from where is the data?
From the Pi?
From the chocolate, yes, from the pie. Okay, what's the problem with this? Okay, it really, we are not showing the data from the IoT Central. We're just showing a Power BI report. Okay, to convince the boss is good enough, but afterwards we need to deliver the goods. How we do it? I said IoT Central, it's absolutely managed by Microsoft. Inside has an IoT Hub, which you cannot access, even for debug. And a lot of stuff that you cannot access. What is the way of doing it? Okay, so the simpler way. Let's get, I have a Google here. So it will be something like this. Power BI solution from Azure IoT Central V3. That would be an idea, yes? That was also my idea. I said, I built my presentation around it. It will be epic. It will be wonderful. People will really cheer up. And let's try it. Let's see what's happened. Yes, yes. And of course, I asked.
Here's a chocolate.
Thank you. And this is how I got fat. So the answer from Microsoft, this is deprecated. Did you try searching with Bing? And now I just asked Microsoft directly, look what happened with this. And they said, this solution is deprecated. And I'm absolutely certain that they will come with something better. But not now. Now you do not have this. If you have already a solution using this, it will work. There will be some interval for deprecation. Also, there is something. If you are looking on LinkedIn and you're following IoT topics, Azure IoT, or following Oliver Block and Ranga Vandamundi, I hope that I did not kill his name. Ranga published something on how to use Power BI embedded in IoT Central, but no details. It's just, look, this is the blog, you can use it, stuff like this. Most probably this will get also out, but still. Also, I'm mentioning that we have a project that we need to use Power BI. How dare we're going to do it? Of course, when I asked Microsoft, they said, look, there is a way. Yeah, always there is a way. It's not the way I, okay, this one doesn't work.
It's not the way.
It's not, this one is giving this is the way that they recommend of doing it now. So what's the story with it? We'll try to go logically. First, you need to get data from IoT Central. We do not have access to the IoT Hub. So how we do it? There is a way. So let's stop this and get rid of it. And let's see where it's IoT Central. IoT Central, come to Mama, app source internet. Okay, we always can go back. IoT Central. So I'm always getting lost. Let's go here of this one, Azure IoT Central Home. And you'll see, okay, my apps, which are, this is a demo tenant. So this is the one. Some of the stuff that it was created using their templates. We have something like data export. So what's data export? What are the destinations for it? So let's see a new destination. These are our destination. We can go to my blob storage, event hub, service bus queue, service bus topic webhook. What's really missing here? I really would love to have some kind of Azure SQL, but we'll get to that later. So they recommend that you use Azure Event Hub, and afterwards you connect with the, let's say, Stream Analytics. I have created this. I've created I've created an Event Hub namespace, an Event Hub inside, and we get into the Stream Analytics. Okay. Afterwards, they say that you connect to Power BI, and I'm okay. Here is a small fly in the ointment. I here do not have Power BI Pro. But let's see, they change also the experience when you try to connect Power BI. And also another fly in the ointment, I did not upgrade the workspaces in my Power BI tenant. But let's see how it behaves. So we want a new output. And we want to be Power BI. So how it's going? It's going from, I'm going data, I'm exporting from IoT Central, I'm going through an event hub. The event hub is going to Stream Analytics. From the Stream Analytics, with that as a select star from now into Power BI, from it should get me data. So call it somehow. It's a good name. Because, I'm on the free. Let's use this. Here, we'll put some names again, but let's get the grouped workspace. I'm going to my admin center in Microsoft 365. Again, this is a demo tenant. Wonderful. But this will load. So getting to the workspaces, this is the free version. I'm emphasizing this is not pro. And here I can take this one and put it where am I? Where I was here. So let's see, group workspace, and authorize the connection. This was also before. Now let's get this one, and I have the password, no problem. Everything is hunky-dory here. So let's click save. I've clicked save. Nothing happened. Okay, I've said this is because I'm on a free tenant, so you cannot use it in this manner. And I suspect maybe have something with upgrading the workspaces. But my question is, this is the optimal way of doing it? Yes or no? 50%. We still have chocolates.
Probably no.
Probably not. Okay, the question would be why.
He's going to answer.
Here we have an automation. When we select as Power BI as destination, they automatically infer database schema. But that database schema that inferred, that cache of database that it uses Power BI, it's suboptimal. It's not a good way of doing it. So, in a way, this is a blessing in disguise, because we are not able to create with my tenant. If you have a Power BI Pro, you can do it for sure. And also you have the documentation from Microsoft. If it does not work, you can go really to that customer support and say, yeah, I want to make it work, it should work, look at your documentation. But it's not optimal. It's not something that you should use in production. What is the optimal way? Is that you should write it someplace, like in a database. Okay, let's try this. So as you have seen, if you've been a bit attentive on the portal, you see that I've created already an SQL server database, Azure SQL database. So it means that I created the server, I created the database. So the idea is to get from the, let's say, the route that we have now, IoT Central, Event Hub. We like Event Hub. It's good. Stream Analytics and SQL database, and from SQL database to get to the Power BI. Let's see how the stuff is working. Let's start running this job, because this is implemented. I'll say, I suppose that showing you how you create an Azure SQL database, it's really something that you know. Again, starting Stream Analytics, it takes a bit. If you have any question besides now, up to now, or I bore you to that, or you need...
No.
Okay.
Katalin, while this is running, let me just go to the microphone. In decent conferences, people will bring the microphone to us.
This means that there is no speaker's dinner for him.
But anyway, one of the things you can do about the schema, if you just want to do some testing with the IoT, instead of sending that to a SQL database, you can send it to a Cosmos DB database, which accepts pretty much anything. And then you can use things like Synapse Analytics and things like that.
But
so that you can read it in the SQL world. But that's an idea.
I need to read it in the Power BI with the field.
But I don't mean putting this into production. I just mean having a look at what the data is. But then you have the next step, which is extra work.
So this is now running. Let's see how the stuff is looking on the down below. I have a strange resolution, but because we'll start seeing some strange stuff here. Okay, nothing yet, but as we know, stream analytics needs the time to spin up. Like everything in Azure, mostly resources spend time spinning up, and afterwards, in fact, as a, let's say, as a bit of trivia, the only part of Azure which is real time in papers, it's stream analytics, but the discussion is it's real time from the moment they got the data at the gate. So up to now, the solution is spinning up and it's starting getting data. So you see it in also in some other scenario. So we are still somehow in time, but I'll try to anticipate. This won't work. Why? I missed one step. Because I just created a database server, I created a database. I created the connection. What's missing? What's the difference? The difference for lazy people of between getting the data directly through Power BI or getting the data through SQL.
Isn't it faster to use directly to Power BI? I think it's not necessary.
That we talked before. It's not faster because the cache system that use the Power BI and send it directly is suboptimal. But you are hitting something. When they're sending directly to Power BI, it's able to infer the schema. SQL Server does not. So you need to create a table with the structure of the data. So let's see how the data, you see now the stuff had begun to, they say degraded, because he tried to send a table, but the table has no structure. It cannot infer from the data arrived the structure. Okay, and now you'll see, of course, Katalin had created the structure. And I say, look, remember, I'm Romanian, so it means I'm lazy like shit. So it's no risk of me creating the structure. And let me show you how the structure should look. And then this is like a trick. Let's query. Let us first stop this stuff. Now I'll show you because IoT Central really loves their JSON. So you need to create a table who will get that JSON in. So you will see the complexity. Just a second. To stop.
Seconds after the message.
Yes, test query. This is again a new facility that I've seen it, let's say, pretty now. Before you needed to create a file as a test query. Now, Stream Analytics knows to get the data from the IoT Central. It show you this is what you get it. So let's see it as raw, an input preview. So let's try to move what we can move, and so this kind of table you need to create with all these fields, with this stuff. So I said, okay,
which you remember by yourself.
Yeah, for this presentation, people get really, okay, to show just temperature and humidity, to create this kind of monster of table. I don't believe that people will get anything more. So if you need to go to SQL Server, which is the recommended way, you need to create this kind of table. The message sent depends on the devices you use, the device templates and all the stuff. It will be the recommended way. I really believe that Microsoft will find a workaround to make it far simpler to get data directly into Power BI. I said the greatest advantage of Power BI is that you have mobile dashboards. Of course, what you created as dashboards, you can see them as tiles in IoT Central. So that's anyhow the message. Use IoT Central, especially when you're starting, because I was able to create almost anything that I wanted on it, with some limitation. If you are really stickler about the look, no, it's not good for you. But if you have some flexibility on the look, you have everything there. Also, you can embed there some external website as Power BI, and you can still have mobile dashboard with Power BI. The export, it's the way out from it. Bear in mind that there are services which are moved very fast. IoT Central, it's one of them. I'll say we started this project with IoT Central in June. Up to now, we upgraded twice the templates because they change it twice. But I'll say the nice stuff that they put on the templates as the graphicons, which is super. Yes, it's not Power BI, it's not that level of analysis. Okay, that will be the question. If I want to have the data inside time series insights, I believe that you can do this also if you are connecting Even Hub, the Even Hub to time series insights. But bear in mind to have another consumer group. Time series insights takes all the data all the time. So he always wins as a service. So other service that you have connected to that Even Hub, if you are using the same consumer group, won't see any data. So let's see on the time. We have some around 5 minutes. I believe it's top of the hour. And okay, let me try a bit to wrap up to all this. So I'm trying to getting you back. Here you have documentation as Microsoft recommends it. You also can test it. They have a sandbox. I cannot show the sandbox. Let's say this, you can try it again back home, no problem. You see it working. I put all the links. Will be the links to the presentation. Presentation will be someplace on the site. What? Our producer Andre said that it's not something. It's not. These are pretty much the links which are around this presentation. Also, feel free to contact me. I believe that this part with the blog, it's already a joke for the last good part of the 7 years. I'm trying to restart the blog. And my big problem is that when I got the information to the quality I desire, the information is already outdated. So I prefer doing presentation because, okay, this presentation, if I did a blog post using that component from Microsoft, which was deprecated, it will be a dead end. Here in the presentation, I show you, look, this is deprecated. For sure, you'll get something new, and also I'll show you the workarounds. And also, we can have a conversation. In the blog, much harder, especially before I had a huge blog, and some people usually, after 2 years, put a question to a blog post from 2 years ago. And this happened to
waiting for HTML6.
Yeah, something like this. But that was an advantage. Sometimes I was looking for some information on the net, solving a problem, and I discovered a good resource, my blog. It was an explanation how to solve this problem. But anyhow, I will do it. And also, I reply to mails. You find me, whatever. So, and question and answers.
My question is it possible to go through without using the SQL and go directly to Power BI? Just because I think that adding additional services, it takes a lot of time instead of using directly Power BI connecting.
Yeah, it's possible. This is the explanation, but I told you before, the cache that Power BI creates, it's suboptimal. It's not that fast. So what you gain some time development because it's doing faster, but you're losing that normal function. It's not a good database, the cache that because Power BI creates a table someplace populated with data. In this case, it's not as good as a real database.
But using SQL, you have another query, another request, another
But
receiver,
it's a
and you have to wait for the response and then to go to the Power BI, which takes a lot of
okay.
time.
Let me give you an analogy. I want to deliver a bottle of milk, and I have 3 rally cards to deliver the milk, and I have an all cards that I push. Power BI is the card that I push. It goes to the door. I have 3 rally cards. Yes, I change the milk between them, but it's a rally card.
Yeah, fine. Okay,
So that's the recommendation. Also, I was saying exactly like you. As somebody who really knows database engine, he took me and I was numbered afterwards. I was knocked out. Explain me really why it's not that fast going directly to Power BI. It's good for you for a demo. It's good for a small data. But if you are going to the production,
yeah,
use a real database.
The logic is normally when you are adding additional applications or whatever it is, when you're adding additional things to the project, it takes more time. But in this case, you say that adding the SQL database is better than going directly.
Because it's you're using a rally card instead of a hand card.
Yeah. Okay.
It's a better database. It's a better database engine because they create some place in the memory on not that powerful server like the SQL server, because SQL server has some hardware allocated in the cloud. These to materialize your data. The plus the infer the schema. I would love to be lazy and get to the Power BI, that cache database, and get the schema from there and import in the SQL server. That I would like to do. But that would be a topic for another day.
Okay, so the last thing I'll ask you next time, when you're writing your presentation and you're writing thank you and благодарю, write благодарю in Romanian. It will be also good for us to learn something new.
Yeah, well, okay, well, I was saying, we plan to do, hopefully, a Data Saturday next year in Timișoara. Come Timișoara and find out how do you say it. So, other questions? So, we have chocolates. Who wants more? So, yeah. Okay, one for you.
This DDB is DBD.
To be determined.
Yeah, it's the opposite.
Okay, whatever. Anyhow, it's no blog. So, thank you very much, Dario. Hope to see you next time. Also, the next events of Data Platform, I believe, in
night of October.
Yeah, of course, I will be there. But that's because anyhow, it's good pizza and very good organization and stuff like this. So, thank you very much, and see you next time. Stop sharing.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Data is super valuable asset in today's business. Data-driven decisions means 23 times more success in attracting customers, improving the bottom line, and future-proofing the company. We understand your data, your business goals, and connects it to time-proven and disruptive technologies, solving your pains. Welcome to the world of digital transformation. Data are the very heart of your company, and we provide you the best option for collection, storage, and analysis of your data, providing you with real-time insight and data decision-making. Seamless flow of data enables data-driven organization and is the basis for data democratization. We future-proof your company, leveraging data to extract the optimal value. Digital transformation requires all types of data you probably have. We gain insight into them with cutting-edge artificial intelligence and machine learning technologies. Artificial intelligence and machine learning bring data game on a new level, increasing exponentially the level of accuracy and prediction. Result: end of low-value repetitive tasks. We provide you with end-to-end solution stemming from your business goals and leveraging data to understand and sell to your customer by delivering campaigns, marketing strategy, and UX UI. One-stop partner, global presence, data and AI-driven, marrying the best of business, technologies, and creative. Digital transformation with Adestra is your path towards data-driven future.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Data Art is a global software engineering firm with a uniquely human approach to solving problems. We have teams of highly trained engineers with over 20 years of experience. Everyone upholds a deep understanding of the industry sector through ongoing technology research. People first. Relationships are the foundation of long-term value generation. We hire people for the long haul. Projects change, but our employees remain with us. Commitment to people is the main and absolute value for Data Art. Data Art doesn't have a rigid hierarchy with a single leader. The flat and decentralized organizational structure is beneficial to Data Art's flexibility. Data Art's organizational structure is based around projects. We enjoy flexible schedules, vacations, and work locations, both at different developmental sales and centers, or from home. Data Art is built around people who want to earn a living using their professional skills and talents with minimal limitations on their personal freedom. A lot of people are happy to work for Data Art and stay with us for many years. They have the opportunity to learn, gain experience, and grow. Join Data Art.
Hold up.
events. It is very important to have support and very strong team to be possible to organize everything online and in person. Thanks again, and I will try to share just a few things about me. My name is Michiel Mateev. I am solution architect and technology consultant, and I'm also a member of Microsoft Regional Director Program and MVP for Data Platform and Microsoft Azure. Last 7 years, I work mostly on IoT solutions, and probably last 10 years, I work mostly on Azure solutions. What is the high-level agenda which we need to cover? First, we will have some overview about Edge solutions and IoT Edge. And after that, we will go a little bit deeper with Azure IoT Edge architecture, some specifics. We will go a little bit deeper in some specific cases. We will talk about some good practices, and we'll try after that to demonstrate some demos. Probably most of you have some overview about IoT in general, and you know that it is one of the fast-growing areas in IT industry. Actually, number of connected devices grow exponentially because more and more machines and different devices stay connected. Different kind of wearables, different kind of healthcare equipment, everything or almost everything in your home is already connected. Your vehicle is connected, and most of things in urban infrastructure also is connected to some services somewhere in the cloud. I can make a summary that about business domains, nowadays already we have IoT in all areas or almost all areas of our life and all business domains, even areas which in the past were not considered like related to Internet of Things, now use live connection to have continuous interaction and communication with backend services. It is from a long time for logistics, vehicles, industrial manufacturing, and nowadays also a lot about healthcare, energy area, smart city and urban infrastructure, and even for fintech and insurance. Now we have almost everything in the context of Internet of Things, direct or indirect with technologies which work in this context. This topic is more about IoT Edge and Edge computing, Edge analytics. It is something which stays more and more important also nowadays. Edge concept is mostly related to usage of analytics power on site, because in history of IT industry we have different flows. Initially everything is actually on site with workstations and personal computers. After that everything stay remote in the cloud and some data centers, and now we have modern solutions where we have balance between computing on the edge and resources on the cloud, somewhere in different locations. Quite often we have quite difficult, quite complex topology. Sorry. Why we need to consider edge concept. There are several things. First, huge amount of data never will be used long-term for some future analysis. We usually have data which is generated from different sensors. Part of this data is needed short-term to some fast analysis to have immediate response for possible problems, fraud detection, tracking of some specific machines and services. But for overall analysis, you just need part of this data. And usually it is too expensive, like computing power and indirect as resources, to transport all this data to the cloud and to analyze this data to the cloud, store this data, or think in more complex way to keep or not to keep this data and to return this data to devices. And we have several important cases here. We have actually, from one side, latency. Latency, because if you need immediate response, it is quite challenging to have such solution only with remote analytics. Because when you have emergency systems, for example, brakes engine of vehicles, and when you have some devices and logic which control production line, you need immediate response. You cannot wait few seconds, for example, which can be because of physical limitation of transportation from your location to remote services, analysis, and receiving back data for some kind of result and next steps. Another one is reliability. Now we have pretty well connected solutions, but still it is not possible to say that you have very high SLA, especially for distributed solutions, where you have really prove that your downtime will be pretty small. So it is possible to have some technical issues, or if you have especially vehicles or logistics, to have longer timeline when connection is not very good. Even if connection exists, but it is not very good, it could be an issue. And the third one, important case, is privacy. Privacy in the context of regulations from one side, and from another side in the context of real understanding and moral about privacy information for specific persons. Because for many specific solutions, including healthcare, including fintech also, information should be actually not exposed in locations where it's not sure if this information can leak in one or another way. From another hand, if information is related to citizens of specific area and region, it could be also under regulation to keep this data, especially in this. So privacy is solved in most of cases when we are using also edge solutions. But I would like to say that in the modern IoT edge solutions and in general edge analytics, we have smart balance, smart distribution between analytics on edge and analytics on the cloud. And this is actually the main idea of modern solutions which work also with resources, analytic resources on the edge. Usually, when we have edge computing, we have similar functionalities for processing and analysis data close to our sensors and devices as those which we have on the cloud, but of course we have many details regarding to what is reasonable to be analyzed on the cloud, what is reasonable to be analyzed on site. And we will talk about this. When we have high-level IoT solution, we have from one side different sensors and devices, so managed objects. These solutions are connected with gateway devices. That means devices which are connected via internet to backend services. And we have from one side analytics, which is in on-site infrastructure, and analytics, which is actually in the remote structure. How we exactly can have benefits from such kind of solutions? Why we really need to have similar kind of design? It is much more flexible when you have edge computing, because also part of your logic, what need to be processed and where these data need to be processed, can be in your analytics model on the edge. So if you have, for example, different sensors, for movement, sensors for light, camera, you can have usually on the edge this logic based on specifics for your solution to process part of this information on site or to process part of this information remotely. We can summarize that actually edge computers are responsible for decision how analytics to be distributed. And this is the main idea. But we will talk a little bit more about IoT Edge. And the specific reason to talk about IoT Edge is because from one side, IoT is also related to analytics, and the second is especially related to Microsoft Azure. Edge analytics for Azure solutions started with IoT several years ago with release of so-named Azure IoT Edge framework, which supports actually any kind of analytics. And that's the reason to talk about analytics in general, but framework is named with IoT in the whole name. Just it happened, but it is exactly analytics on the edge. We cannot say that it is only IoT. If we go back to IoT, we have specific cases which we need to solve also in such kind of solutions. First, we need to solve these three cases which we already discussed about privacy, about latency, and about reliability. Second is related to optimization of the cost, because when you have smart solution where you can process part of the data on site and part of the data remotely, you can have the right balance to optimize your cost of the solution for development and for operational and also operational cost regarding to the goals which you actually need. Additionally, you can have pretty similar approach nowadays using containers and to deploy containers on your edge devices. Many years ago, this concept used to be mostly like good concepts for the future, because devices were not so powerful. But nowadays, most of devices have no any problems to run containers. We will talk exactly about Azure IoT Edge, where also is used lightweight version of Docker framework, which is the default engine for running of containers. If we talk about Azure IoT Edge, we have already some interesting and more specific details. From one side, Microsoft Azure has set of services considered for different types of IoT solutions. Compared to different vendors, for IoT, you can find more services with specific functionalities in Microsoft Azure, and you will be able faster and easier to set up your backend of IoT solutions. And we have the very similar case on the edge, where we have IoT Edge framework, for which we will talk a little bit later. And this IoT Edge framework provides the same developer experience for many services to work with these services and to implement solutions for these services in a very similar way, like with other services. I mean, for example, cognitive services, it is the same with Azure Stream Analytics and some different services. So you have no need to learn absolutely different. You can actually reuse your knowledge. And because we can have devices which are connected, field gateway, and many leaf devices, which also can run Edge framework, you can have a very powerful set on site. Even we can say that we can have multi-layer solution even on the edge. We have also some good things related to common trends for edge devices, because devices stay more and more power efficient. One of the cases in the past, which used to be problem, is that devices with more computing power, of course, use more resources. Now devices is much more optimized, and also additional power comes with additional security. In IoT solutions, usually devices are the weakest part of the whole solution in the context of security, and we need to protect first devices. And quite often we have some compromises regarding to encryption and algorithms which are using in cryptography, mostly because we have limited power for edge devices. But more and more powerful devices actually bring this opportunity to have also better security. Regarding to different platforms which are offered on the market, there are really different edge analytics platform. Main cloud vendors offer own edge analytics platforms, and also some specific IoT solutions, for example, like PTC with their suite ThinkWorks have own solutions. But at least my impression is that Microsoft Azure IoT Edge is the simplest one and the richest one, so you can make faster and easier edge solutions. And they have more common vision to be possible to reuse different components, which is very important from the productivity point of view. And we already discussed that almost all business domains also can take advantages from edge analytics. Additionally, with new mobile networks, when connectivity stays better and better with 5G networks, this case stays even much more effective. If we talk about Azure IoT Edge architecture on the high level, we have several modules or several components. Let's say several components because model here we will use in different contexts. We have from one side IoT Edge runtime. This is actually the part of the platform which is used to be possible to run containerized applications as models for edge devices. You should install this edge runtime into your devices. All functionalities are implemented like edge models. We will talk about these after few minutes. These models are implemented as containers on top of Mobile Framework. Mobile Framework is lightweight framework, subset of actually Docker container supporting framework, which is more than enough for these purposes. We have additionally monitoring with IoT Edge Cloud interface. This is part of Azure management portal where you can manage pretty easy these edge devices. So edge devices are managed pretty similar like other IoT devices. But here we have also this tight connectivity between IoT and any kind of edge analytics, because to have edge analytics, you need to have connectivity. If you have connectivity between devices and backend, in the current case in Azure services, actually you have IoT concept. You have some kind of IoT. So that's actually the simplest explanation, probably how IoT and edge analytics are very tightly connected in modern solutions. And it is not only in Azure IoT Edge context. In general, these technologies are tightly connected. You cannot have edge devices without IoT component. Let's see how we have the common flow. We have different kinds of devices, of course. Some of devices can be without edge computing, different kinds of sensors, lightweight devices with different purpose and limited computing functionalities. But usually these devices are connected to the backend with field gateways, which in most of cases, not always, but in most of cases, are kind of these devices. Because if you have connectivity, usually you have additional functionality, you have need of computing power for gateway functionalities, and this immediately brings advantage if such kind of devices are edge devices. But we can have on this layer here also devices which are edge or not edge, and for connectivity usually we can get best advantages from edge devices. So we have these three parts for which we will talk during the next few minutes. About edge models, excluding some general subset of libraries, everything in IoT Edge is based on models. Even some core components of the runtime also is implemented as such kind of models. So we have something like this schema. You have this Edge runtime, and all models, containerized models, communicate via this IoT Edge runtime in between and also with other devices and the backend. So if you create model, you have no need to think about connectivity, security. All these things actually are part of the framework. That's the idea. Simplify development of such kind of models. And we can cover security standards, monitoring, communication, most of the things in this way. It is actually something which is considered quite seriously, and solution work in this way regarding to the best architectural practices. We need to manage these edge devices. That's the reason to have this edge cloud interface. Of course, it is possible to manage IoT devices usually also using common light interface and using SDKs, but the simplest way, usually, if you need to monitor some devices, or at least in the context of development, research and development, you can use IoT Edge Cloud interface. We will actually see this pretty soon. And you have connection to devices in the to edge devices and models in pretty similar way, like everything we should do with just devices for general purpose, not edge devices, but IoT hub. So everything actually comes the subset of management for IoT hub. If you have IoT Edge framework, the best advantage to use such kind of IoT Edge framework is when you are using IoT Hub. Why? Because from one side, you have Edge Hub also on the devices. This Edge Hub is already designed in a way to communicate in a very simple way with IoT Hub in Azure. And the whole concept is to have this framework and to have optimized communication with IoT Hub. So in the context of good practices, there is no some significant reason to use different services, because you need to have much more custom implementation. With IoT Edge framework, IoT Hub is the easiest and right option to implement communication. And this IoT Hub works together with IoT Edge Hub, which is something like a local proxy. It has subset of functionalities for IoT Hub in Azure. Some things are not supported. Some protocols like HTTP, for example, are not supported, but many functionalities are the same, and you can use the same approach to communicate with this hub. You usually have no need to make some specific logic. Usually in your solution by IoT Hub, you can configure Edge Hub, and after that, your models actually don't care how connection is implemented, which is the main idea. There are many services which we have in Azure IoT. Some services already have Edge versions. Some services still haven't. Some are in details about which services are in development, but you can see stream analytics, you can see blob storage, you can see also SQL database on the edge, Edge Hub, and you have for cognitive services and machine learning also very good opportunities to reuse the whole power using also local models. Usually, especially for analytics, local models work together with backend services. For example, it is the same for cognitive services. In most of cases, we have part which is on the edge and part which is on the cloud. And depending on the specific implementation, we can have a need of additional step to step everything, or everything will be transparent. But you have no need after that actually to think about a balance, what will be executed on the edge and what will be executed on the cloud. If there is a connection issues, usually it is possible to persist this information for specific timeline. Even this is configurable, and after connection is restored, this data can be sent to the back end. Let's go a little bit more in details, and after that we will have demo. How edge architecture looks in the logical schema. It is actually a logical schema without exact relations between models, but we can say that from one side we have this edge runtime. As part of this edge runtime, we have from one side Edge Hub, we have Edge Agent. Edge Agent is responsible for starting and monitoring of models which are deployed on the edge. You can have many different models, many custom models, plus some models which you can get from Microsoft Azure, some third-party models from the marketplace, and we will talk a little bit later about a way of communication between models. And of course, this connection between devices can be done in several ways. It is not up to models to care about this. It is on the level of IoT edge settings in IoT Hub, which actually can be in control panel or using CLI. So we can have different kind of architecture in the context of edge computing. From one side, we can have direct connection of device. It could be with edge framework. You can have devices directly connected to IoT Hub, and you can have these devices edge or not edge devices. You can have field gateway, which will work in different ways. You can have transparent field gateway where you can have no any specific changes in the local infrastructure. So settings will be transparent, and devices will think, leave devices that they connect directly to the cloud gateway. You can have changes of the protocol. In this case, your devices, lead devices behind the field gateway will be not visible directly from the configuration of IoT hub, and you need to have additional things actually to configure these devices. You can have just changes of identity. Your devices can be with different names and to have different logic to find each other on the edge, but on the back end to be actually recognized in different way. There are many reasons for this. Sometimes because of compliance, security, but also regarding to some specific technical cases. So we can have and you can actually set up this general for devices and to use any model, absolutely independent. When you install your IoT Edge framework, installing a IoT Edge framework actually can be done with some tool for installing a library for your device, for example, Linux-based device, with clients for installing packages. You need to have setup of several main configuration settings, and actually, usually by IoT Hub, when you create, in most of cases, it is pretty easy using this cloud interface. You can do it there. When you have this framework, first Edge agent is running and stay alive. We will see a little bit. After that, you can add additional models, including also Edge Hub. Edge Hub is part of this framework, but it is also realized like model. Edge agent also is realized like model in general. One very important thing is that using such option, you have no need to make more complex logic for your devices if you have models deployed in different regions or for different tenants. Under tenant, I consider mostly organization. Why? Because you can configure your models with specific settings for specific region in a simpler for management way, instead to have for each these devices complex logic which need to be configured in the same setup for different regions. So before to have some demos, some good recommendations when to consider IoT Edge. Of course, we already mentioned some of these things. Reduction of the cost, mostly because of implementation effort, which is minimized, and also regarding to possible changes and change management. We have here out of the box offline operations. This is something which is also part of the framework. So you have no need when you implement some model, for example, and this model needs to communicate in the standard way. to persist in a specific separate way this information and to have specific logic when to send this information. Most of the things you can make out of the box automatically. For IoT Edge platform, as we already discussed, we have set of options which we can use. Even we can use as models Azure functions and some quite modern concept for this. Model deployment and upgrades is another thing which we will talk a little bit later, and we'll try to share some case. We will have demo regarding to cognitive services on IoT Edge. When we are using cognitive services, usually we need to follow the concept with custom creation of backend service, implementing cognitive services, and a specific model which will use partially this service using credentials of power of the backend. But again, this balance will be managed automatically. You have no need to make something custom. About deployment for cognitive services, it is like a normal model. I will show you a little bit later how it happens. When we talk about some custom models, like some machine learning services for IoT Edge, actually we need to create our model, train our model, and deploy it like container on the edge. And we can, as model, to redeploy new versions of this straightforward. When we are using Azure Machine Learning Service, usually we do not have exact requirements that we need to have, like for cognitive services, mandatory connection with backend services. You can have custom solutions with or without connection of your machine learning service on the edge, and another one which is on the cloud. Regarding of security and privacy, we can talk a lot, but our time is limited. So from one side, I can just have overview, high-level overview. You need to secure any subpart of your solution. That means you need to secure, of course, your components on the edge, but each component on the backend, because modern IoT solutions are implemented in the context of zero trust, and it is more relevant now with distributed solutions. Each component needs to be protected. Doesn't matter that we have protected gateway services and protected connection. For communication, when we are using IoT Hub, the IoT Hub advantage is that it reuse one of the best design patterns from the security perspective, service assistance communication pattern, where you have never direct connection between edge models and backend. Of course, there are many details. We will cover this probably in another session focused on other subparts of IoT solutions. What we need to know about deployment? Well, you can have manual and automatic deployment. You can do this pretty straightforward. Just you need to have for your devices Edge enabled option, and your devices need to have this Edge framework. That means if you use, for example, Linux device and there is not Edge framework, even if you actually register this device like Edge enabled, it will be not possible to support this functionality. You also can have device provisioning using device provisioning service. Again, pretty straightforward. You have in both options using web interface management service and command line interface with just changing some options. Another case is how exactly to have deployment, because we have several different concepts. One is phase deployment. That means you can have deployment where you have actually each module very decoupled from other. These have advantages and disadvantages. Advantage that you have no dependence, disadvantages that you have really less functionality. Under dependency here, I consider not to need some library or something like this, but one of your models, for example, for some functionality, to need to call another model, for example, which is expected to be already installed. So we have from one side phase deployment, where you actually have this kind of ACA package deployment, and you do not rely on some layers. And you have layer deployment, which is more effective in the context of timeline for the deployment and storage and number of modules, but you have more dependencies. You have more dependencies, not direct, but indirect regarding to the overall logic. The second one is more effective when everything works, but you need to be much more careful and strict when you have deployment. These are actually the two main options. And in the end, yes, you need to have this checklist. You need to check device configurations. You need to have the right strategy for deployment. You need to have good container management. Container management is directly related to module management and configuration of models here, but models also have YAML configuration files for containers, plus model twins, which is pretty similar to device twins, and it is simplified implementation of the digital twin solution. You need to consider also networking in two aspects: networking for the whole on-site infrastructure, and networking between edge and devices in general and backend, and the overall solution management. How you will prefer to do this, because regarding on this, you can have different details. For example, if you need to change the protocol, if you are using, for example, old devices, old smart meters, for example, with different protocol or whatever, and you need to change protocol, that means changing protocol automatically is limiting, for example, part of management functionality. Now, for the last few minutes, we will try to have demos. For demos, I think that we need to change the shared screen. Let's see if I will be, yes, I will be able to share this way, but need to have approval from the admin. So till the moment when this is possible to be done, actually, I will just open my screen. Yes, I need to change my screen because from slide deck I'm switching to demo.
Just tell me when you're ready. I saw your screen.
Let's try to do it. Share.
Okay.
Can you approve it? Okay. And now I will go to Azure Management Portal in general. I already have Linux-based virtual machine, which is deployed. This one. And I already installed in this virtual machine IoT framework. So about the sharing, give me 1 second. Also for local presentation to stop. Okay. Okay, perfect. Hopefully. Are we on the same? Yes, but again, not. So can you ask again the admin? This is just part of the complexity of our solution till the moment when I have approval for sharing of this screen. You can see behind me actually this screen even on the streaming. So I already pre-installed Edge framework. It is possible to do this actually connecting with SSH to your virtual machine, and we need to have a set of steps. The procedure takes a relatively long time, more than an hour. Usually, if we need to step everything, that's the reason to not consider this as part of this presentation. And when we have this framework actually set up, we can also have installed modules for these devices, also custom models. Let's go to IoT Hub. Already have prepared IoT Hub. Of course, we will have just overview of part of functionalities here. For more details, we can discuss later, even offline or in social networks, different details. I already have one sensor added using Azure CLI, but you are able to add devices also from user interface. You need to actually add the unique ID for this IoT hub for the devices. You have several options to have token using symmetric key or based on certificate, and based on this, actually, you can generate required credentials. For example, something like this. You can add also child devices. Well, your device, when it is added, you need to have actually several steps to have installed this runtime and to have request this device to be connected from the device side. It is not possible just everything to be only from the IoT hub part. After that, when you have connected devices, you are already able for specific edge device to add different models. It is possible, we have already several models, it is possible to add models which are, for example, marketplace models, Azure Stream Analytics, or IoT Edge model, which can be some model which is custom model. Marketplace models are models which can be from Microsoft or not from Microsoft. We have these options also for many different types of services, like, for example, for cognitive services. And these devices have the main setup. You need just to reconfigure this device. Let's now check this sentiment analysis model, which we already have. You have additional options to connect for cognitive services using specific credentials. You have also settings for your container, and you have model twin settings if you need to have specific settings. In the current case, we just have no need of specific settings, but if you need to have configuration of your model, the most straightforward approach is to use model twin. For those of you who are using Azure IoT and IoT Hub, probably this approach is pretty straightforward because most of you probably already use IoT Hub device. But it is actually JSON with two groups of settings. These are settings which are for configuration which need to be set from the backend, and reported or current settings which actually represent the current state of the model. And the model, in the same way like device, is reading what is the desired settings and trying to make equal current or reported settings to desired. I already have, I will try to be very fast. I have cognitive services also deployed here, and I already have, based on additional settings, prepared a request with Swagger to my device with specific IP. If you turn off device which is virtualized, for example, for testing in Azure, and after that turn on this virtual machine and you have no reserved address, you need, of course, to consider that your IP address can be changed. So, our actually cognitive services models reports that it is ready and it is possible to make tests using, of course, different test setups to prove that it works. In general, this is the high-level concept how edge models work. So we are connecting to our edge device, which is virtualized device. Yes, I need to change some settings. It is possible after that to install edge framework. After that, you can configure your IoT hub to work with this device. That means adding of the device to IoT hub, getting credentials, connecting devices, and after that, you are able automatically to add models to these devices and to change these models, configure these models, and take the whole advantage of Azure IoT Edge for different kinds of analytics. That's everything which I wanted to explain today. Thank you for attendance and hope to see you soon.
Saturday Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
Data is super valuable asset in today's business. Data-driven decisions means 23 times more success in attracting customers, improving the bottom line, and future-proofing the company. We understand your data, your business goals, and connects it to time-proven and disruptive technologies, solving your pains. Welcome to the world of digital transformation. Data are the very heart of your company, and we provide you the best option for collection, storage, and analysis of your data, providing you with real-time insight and data decision-making. Seamless flow of data enables data-driven organization and is the basis for data democratization. We future-proof your company, leveraging data to extract the optimal value. Digital transformation requires all types of data you probably have. We gain insight into them with cutting-edge artificial intelligence and machine learning technologies. Artificial intelligence and machine learning bring data game on a new level, increasing exponentially the level of accuracy and prediction. Result: end of low-value repetitive tasks. We provide you with end-to-end solution stemming from your business goals and leveraging data to understand and sell to your customer by delivering campaigns, marketing strategy, and UX UI. One-stop partner, global presence.
To stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
DataArt is a global software engineering firm with a uniquely human approach to solving problems. We have teams of highly trained engineers with over 20 years of experience. Everyone upholds a deep understanding of the industry sector through ongoing technology research. People first. Relationships are the foundation of long-term value generation. We hire people for the long haul. Projects change, but our employees remain with us. Commitment to people is the main and absolute value for DataArt. DataArt doesn't have a rigid hierarchy with a single leader. The flat and decentralized organizational structure is beneficial to DataArt's flexibility. DataArt's organizational structure is based around projects. We enjoy flexible schedules, vacations, and work locations, both at different developmental sales incentives, or from home. DataArt is built around people who want to earn a living using their professional skills and talents with minimal limitations on their personal freedom. A lot of people are happy to work for DataArt and stay with us for many years. They have the opportunity to learn, gain experience, and grow. Join DataArt.
Hold up.
Okay. Okay. Am I on? Okay. All right. Hi, everybody. It's a pleasure to be here. Though not still in person in Plovdiv, but I'll be joining the speakers dinner. So I'm very hopeful to see whoever is in Plovdiv, whoever is staying in person in about 2 hours while I'm still in Sofia. Today, I will not be talking about my usual topic, which is energy. I'm quite excited to talk about a topic joined by a close friend and partner, Ivan Tsenov, who will be introduced a little bit later. And the purpose of the presentation today will be AI in healthcare, in a complicated matter as DNA modeling and methylation, and how do we apply artificial intelligence and a subset of biology called epigenetics to sorting out real life examples. I'm quite happy to thank our sponsors, us included, as Anthill, also EPAM, Stripes, Datis, Microsoft, Inspire ID, Duster, DataArt, and most importantly, the organizers, everybody who is organized and coordinated by Mikhail Matev, for the opportunity to talk again. Most of you guys know me, and today will be a very specific challenge talking about a topic which I'm as usually investing. That's an exciting, hopefully, startup that we're going to create quite soon, and that now deals with, well, less mundane topics than my usual wires and energy, meaning healthcare. A note about myself, who doesn't know me, I'm normally rambling about what can we do about smart energy, drones and stuff like that, and how it connects to Azure services and AI. So today, my new interest is also how to, take all the knowledge learned and how to apply it to a completely new vertical, completely new dimension. What is going to happen today is I will talk about what is epigenetics, what is DNA methylation, what is the importance of those, where is the intersection with AI, and Ivan will join me in my track to talk about more about our current experimentations with AI modeling, challenges and opportunities, and what we've learned comparing to what exists and we've been researching together as a state-of-the-art situation. Okay, epigenetics and DNA methylation. So epigenetics was first coined a long time ago. It was 1942 by a scientist called Conrad Waddington, and the word comes from the Greek combination of epi, which is above, genetics, which basically means it's a study in the field of genetics about cellular and physiological phenotypic trait variations that are caused by external environmental factors. So basically, to understand epigenetics is like what really makes the genes perform one way or another. And what I've been talking today a lot is about what basically switches on and switches off certain genes and their expression, which basically results in how do we feel, how long we live, what kind of diseases we have or we don't have. So it's basically it's a very old term, but still quite an emerging area of scientific research that comes all the way back to our childhood. But what's exciting, it's also now tries to understand how external factors basically affect our body and our brain. Until recently, the influence of genes was thought to be kind of set in stone. So basically, you are born with good or bad genes, whatever, whatever happens, it only happens in your childhood. But how it actually operates has long remained a mystery, right? So basically, what happens is now, because there was a lot of fuss about the Human Genome Project, we now understand why we're albino, why we have blue eyes, why we have, why we're tall, why we're short, but what actually the lack of understanding how those things basically interact has born this subset, which I would call a full-blown science now, called epigenetics. So basically, it tracks the interaction between the individual's genotype, age, and what is the important part of this presentation, the factors such as diet, alcohol consumption, environmental factors, stress, and most importantly, it's how do we learn to track it using AI. So basically, the importance again of the epigenetics is not only about what happens in our childhood and what is our current DNA situation, but what happens, what other factors basically dictate how our life will happen until we die. I mean, a lot of people have, would say that DNA sequences are destiny. Again, we already know basically how to make a child with specific color of the eyes, but and this is largely part of the analysis of the so-called Human Genome Project, where over 3 billion bricks, or this called pair of principles, were analyzed finally using high-end computing. But what now happened is, after the first euphoria subsided, scientists began to wonder, okay, right, we know how basically those things work, but linking those to outside factors, is that still a mystery? And this is what we are kind of hopeful to start unlocking soon. A very typical example, which cannot be explained with current DNA research, is if we have identical twins, basically the same genome, they can differ quite a lot phenotypically, and one develops one illness like cancer or diabetes, and the other doesn't, right? And well, why the cells of the body are so diverse, and basically what makes those things develop in a certain fashion, is still a big mystery. So basically, what we are going to talk about today is, how during the development the DNA, operates by accumulating specific chemical marks that determine how much or little or not at all different genes are expressed, and the collection of those marks is called the epigenome. So the point is, how do we understand what basically influences those different genes, and what is the interrelation between different factors, epigenetic factors, or again external factors? How do we track them? How do we collect data about it? How do we crunch the data, and what it basically does to us? An easy way to understand the difference between genes and epigenetics is also if you take the genes are the hardware. This is how we've been born with. The epigenetics is the software. And today, we're going to talk about how do we collect the data about those external factors, how we link them to specific things happening. But the epigenetics is the software that drives the hardware. Basically, it doesn't change the DNA sequence, not at all. But what it does, if you, for example, you have a certain, let's call it a bad DNA, bad gene, that can unlock cancer, a specific epigenetic factor can either suppress or transcribe or open that situation in developing into a full-blown cancer, right? So a simple example, not related to humans, for example, would be an ant hive. Beehive. We being as anthill, we love any comparison to insects. So I decided to take an example with a hive. When within a beehive, I don't know if you know that, all bees are genetically identical. So basically, worker bees, soldier bees, and queen bees, well, how do they develop into a queen, soldier, or worker? And you'll be quite amazed to understand that it's the diet, right? the larva receives the pollen, develops into worker bees, and there is a specific jelly produced by bees. They become like queens. And well, how this is possible? Well, this is epigenetics. This is the exact, simple example of an external factor that can drive a dramatic change. So another example with still not humans, with mice. This is an example with genetically identical mice, which basically were given absolutely different diet. And what happened is that mice, they really looked different, right? And basically, this is a good example how a change may happen not evolutionally, but intragenerationally. So basically, I'm sorry, this is intergenerationally. So it's one generation to another. So we're exploring today what are the effects in relatively short term, which is intragenerational, like within 2 or 3 generations, or intragenerational. So basically, what happens during your own lifetime. So the way it operates, the way mice change color, or it's a subject of a chemical reaction called DNA methylation, or attaching small markers directly to nucleotides. This is directly within the DNA. And one of the cases that is another good example is how diabetes is evolved, which I'll explain later. Further from what we eat, another good example of an external epigenetic factor is behavioral, right? So that's quite fascinating. That also it's an experiment done on mice. That mother rats who licked their kids, they either locked or unlocked specific chemical reaction that basically was a DNA methylation reaction that caused the offspring to develop differently. I mean, same diet, same exposure to other external factors, but different behavior approach. So it's also a good example when you compare to humans how stress basically does affect our own DNA methylation that can unlock a specific disease. So we hear a lot about, that stress kills. This is exactly what happens. Stress creates DNA methylation, which may unlock a specific part in our DNA sequence that can unfold whatever we've been pre-programmed by origin to be predisposed to. So basically, and it's pure chemistry, right? So it's one way to analyze it. For example, it's one of the many ways to analyze it is to track the level of cortisol in your blood, and this is how it basically relates if you're experiencing stress or not. So it's been, I think it's been one of the reports of the World Health Organization that aging now is considered a disease, right? So fight with aging is now on the radar as something that's curable, something that can be changed. And more and more attention is paid to epigenetic factors, which basically are among the primary reasons for aging and any health disorders, as already discussed. So the whole point of applying DNA methylation and trying to figure out what specific factors affect other factors like integrative or compensatory factors. This is basically integrative comes for like cellular functions. Those things can be tracked, can be monitored. It's like stem cell exhaustion, intercellular communication. Since it's an IT conference, I will not go into that stuff, which I personally also am digging in. The point of this is to be able to somehow collect a multitude of epigenetics factors, since they have the primary function for aging and health disorders, to be able to develop personalized diagnostics and preferably personalized treatment. This is where the role of AI starts to come into play, because we being, different systems, mobile systems, we understand the concepts, but we are a different universe by ourselves. And it's, so one drug that's actually a medicine for someone can easily kill another person, or vice versa. Actually, epigenetics and DNA methylation, as mentioned, are now in the root of the so-called epigenetic drugs. Epigenetic drugs, in my understanding, is the personalized treatment that can extract your DNA, add some, science and data science to it, and provide actionable insights, able to develop a certain personalized drug. So for myself, epigenetic drugs is a personalized drug that's been a combination of a DNA analysis and basically AI. How do we collect DNA samples? So actually, as I mentioned, we have a pretty hands-on exploration into this subject field. I'm actually holding a DNA sample kit, which basically is a self-administered kit. You provide blood and urine samples, and you send them over to a laboratory, and this is the start. The approach we're trying to uncover, we refer to it as an omics approach, is basically a novel comprehensive, it's a comprehensive approach for analysis of complete genetic or molecular profiles of humans. And in contrast to genetics, which basically focuses on single genes, genomics focuses on all genes or genomes, and most importantly for our case is their interrelationship. So basically, we're hopeful with the help of AI to study the complex interactions between genes and molecules and how they influence the phenotype. So basically, the phenotype is relates to the disease symptoms in patients. So there's a number of technologies such like next generation sequencing, DNA blasting, but it's all impossible without the approach that's being utilized by AI. My colleague Ivan will basically expand a little bit on that topic, but the point is that we take DNA information, we try to analyze what would be your specific personalized predispositions to a certain disease, and we try to take like a couple of diseases, and we try to examine what external factors may or may not unlock a specific DNA part in your DNA. Okay, so genomics comes from there are different types. There are genomics, the most well known. It's studying the set of genes, basically the genetic landscape of the organism, and there's a bunch of other things. And most importantly for us is phenomics, which is a set of phenotypic traits, such as this is the comprehensive description of disease symptoms in a single patient. Since I mentioned a few times a word that probably nobody knows here called DNA methylation, which is attracting a lot of focus. Methylation is actually a simple biochemical process. I hate to refer to humans as a relatively complex set of electrochemical reactions, but this is exactly what we are, right? And the whole topic of DNA methylation is a transfer of 4 atoms, right? 1 carbon and 3 hydrogen atoms, calling this called methyl groups. So what it basically does, to understand for the purpose of this presentation, methylation is the way to add specific chemical markers to the DNA. It's called methyl groups, and then what happens is the poor or methylation or good methylation influences things like anxiety, depression, unlocking diseases. So again, the whole mystery of unlocking a DNA disease is basically an external factor which attaches a certain marker to your DNA and unlocks something that's been already pre-programmed. It's a biological process, biochemical process. Again, it doesn't change the DNA sequence, but it basically activates or deactivates a certain component. Okay, so I'm a little bit losing time, so I'm now we'll try to explore the purpose of this conversation. I'm sorry, conference is data science and AI. So I'm trying to explain my understanding where there is the AI in the whole equation. Well, first of all, as we've already analyzed, we're trying to find a way to provide a personalized diagnostics, and hopefully, based on the personalized diagnostics, we're trying to provide a way for personal treatment. So basically, the point is to collect as much data as we can and compare those large data sets with specific DNA methylation profiles that, for example, manage the process of aging or manage the specific process of, let's say, diabetes, or something that relates to Bulgaria. I think #1 disease in Bulgaria is cardiovascular and heart disease. As a category. So it's also something that we can analyze, extract patterns, and try to figure out how the specific DNA profiling that's personalized can relate to a set of epigenetics factors, which we can collect, which is one of the challenges, but which we can collect, prioritize, and basically provide insights for people and personalized epigenetic drugs. Within that field, the machine learning could be, it can take a large data set and make prediction for future events, basically analyzing how those interrelations work. Plus, we have quite an advantage in front of us. As you know me from previous presentations, I love to talk a lot about digital twins and predictive analysis. Basically, the point is to create a digital twin of ourselves, find some common things that affect a specific disease that we might have or might not have, and figure out what would be the algorithm that can further streamline, improve accuracy, or make a faster diagnosis and treatment. Right. So, for example, we can develop assistive clinical tools for early detection of cancers. So basically, the point is to take this whole knowledge and start applying to specific patients by discovering patterns that we can take and kind of analyze and start comparing on a personal level. So right now, thanks to also the advent of technology, we have a huge amount of all kinds of data: patient, hospital, administrative data, weather data. We also thanks to the increase and popularity of wearable devices, we have also a constant stream of data on a personal level from the patient. So our it's not a panacea, but machine learning can be the tool that can take all those data sources and actually figure out how to create a model that can be used to, for example, minimize the research time for patients. Like imagine, somebody with cancer, and what I've learned, it takes about 12 years for a new drug to appear, from research lab to patient. And actually, a lot of thousands and thousands of candidates should be really examined and analyzed along the way. So the question is, can artificial intelligence help speed things up? And well, basically, we believe it can. And one of the applications is and the purpose for developing digital twins of patients is perform virtual clinical trials. So basically, the point of our startup is to incentivize, even gamify people to supply any data, and so we're able to include any data from, let's say, wearable watch, from DNA sampling, blood test, endocrinology analysis, and find the right set of tools, the right approach to basically analyze data for actionable insights. Basically, there are some databases that exist. So PubChem, Zinc, DrugBank. So there is already an attempt to, kind of unify all the knowledge. And what we like about Microsoft in this regard, that Microsoft is providing all the tools to be able to, combine all that research and share it with others. So basically, the idea is to use AI to perform virtual clinical trials and get the results, get them anonymized, and put them into like a single unified database, and also take advantage of the cloud computing required, to basically crunch all that data. The point, that the approach is quite largely supported by Microsoft, is eventually prepare a virtual library of chemically accessible compounds. So also we can, start tracking not only early detection of the diseases, but also start, creating, in a virtual space, real R&D on how do we take the DNA data and using the epigenetics research, combine cloud computing with, multiple sources of data to be able also to experiment in the virtual space safely with thousands, maybe at some point millions of patients that participate in our program. So we'll see. And before I pass the floor to my colleague, I'd like to talk a little bit about the needs right now. My colleague will talk about clocks for biological age, like our current experimentation. Maybe Ivan, I know you're listening. It would be nice to explain what's epigenetic clock, what's aging clock, and what is our approach. We started seeing a lot of challenges, actually more challenges than opportunities right now. And part of the challenge is that actually quite an interesting challenge, because most data available is only available for there is a bias towards actually white people, and that basically means that a lot of problems like diseases that are affecting basically less how to put it less privileged parts of the world are basically excluded. So then most epigenetic data sets have actually more variables than samples, so it's actually quite difficult right now for many machine learning algorithms to function effectively. Ergo, we're trying to find a way to collect more data, and unfortunately, collaborative data repositories are not really still existing. So hopefully that part of our efforts will kind of unlock the potential of and the use of having such a collective collaborative data repository. Also what we discovered, and actually I would encourage my colleague to talk a little bit about that. Since we're trying to figure out a model that can give you actionable insights, what's wrong with you, focus on a specific disease tends to ignore another disease. For example, if you have, say, skin cancer, I mean, you may not have skin cancer, but what happens if you have lung cancer and you have overlapping symptoms? So that's one of the challenges as well we're trying to basically overcome. Another problem is that the diseases that really need prediction, like cancer, or what we still call incurable diseases, are still quite rare. So when you have very large data sets, that requires some kind of cross-jurisdiction collaboration, because then it becomes a little bit of a mumbo jumbo and speculation. How do you work with data set? And quite often we have quite incomparable data granularity, so it's kind of hard to compare apples and oranges. And but my colleague will talk more about that. So basically, I would use the few remaining minutes of my time to introduce Ivan, who recently came to Bulgaria. He's a true artificial intelligence scientist, so we're quite happy to have him here. He has, and he will introduce himself shortly. So if you have any questions, I'll be super happy to answer them, because we're running out of time in person, or most of you know my contacts. So I'm passing the floor to Ivan now.
Oops. Okay, starting over. Hi guys, really nice to be here, and thanks Andre. And I'm here to talk a little bit about what the actual AI part of things is, what the data science part of things is, and what are the challenges and opportunities we're seeing. So first, a little bit about me. I'm the co-founder of Figure Out AI. We are an end-to-end AI solution startup in Sofia. I have a bachelor's in mathematics from Tufts University in Boston, where I was awarded the Martin Gutmann Award for a #1 math student in the university. I have a strong background in physics and computer science, but my main career thus far has been software engineering. So I've been able to combine sort of my academic work with the software engineering praxis in the things we're doing at Figure Out. And here is a little bit about us. So we're a young AI team who can tackle each phase of the AI lifecycle. And we can do research and ideation and consulting. We can do data gathering and experimentation, and we can deploy AI in a platform-independent fashion and at scale. So we're really like a one-stop package for any sort of AI solutions. And we've done all sorts of tasks, including images, including text generation, including audio classification. And right now we're doing statistical work with epigenetics. We use an internal AI prototyping framework, which helps us perform very fast experimentation and get state-of-the-art results relatively quickly, which really brings the cost down of a project, because the main costs usually are the work hours of AI engineers. So what I'm basically going to be talking about is first what the actual problem is in data scientific statistical sort of representation. How can we talk about biological aging? What is biological aging, and how it can be measured in a meaningful way? Then we're going to talk about specifically the task we've been working thus far for, and we're going to talk about the data gathering and pre-processing, which is actually the big bottleneck of the whole process. And finally, we're going to be talking about the model and what actually we're using. So to start with what the problem is, we're mainly interested in biological age as a proof of concept for the epigenetics platform we're building. And we have a definition issue, which is what is biological age. We're trying to figure out how old your body is, and what, compare it with your chronological age. So maybe you're 30 years old, but your body has actually aged much faster, and you're actually at a 4-year-old age biologically. Or maybe you're a very healthy person and you're actually, you're 30, but your body is actually 25. So we were trying to build up a statistical definition based on epigenetics of what biological age is. And common sense dictates some things about this definition, which is that for an average healthy person, biological age should equal chronological age. So if you're the very average Joe, if you're 25, then your body should also be 25. Bad lifestyle and sickness should correlate with faster aging. So if you have genetic disease or cancer or something like that, that should correspond to a higher body age, as well as a bad lifestyle. So if you're eating too much McDonald's, you're probably 5 to 10 years older than you should be. And finally, the final part of the definition we really want to hit is that higher body age correlates to higher risk of mortality. So this also correlates with the idea that sickness should lead to a higher body age. And bringing it back to what Andre was talking about, which is methylation. It's a process where an extra methyl group is added to the cytosine in our DNA. So you can see the actual methyl group being added to that molecule. And this leads to inconsistencies in DNA replication, which over time deteriorates the whole organism. And this is one of the main causes of aging. And by measuring it, maybe we can predict how aged our bodies are. And this is exactly what people did in the early 2010s when they developed methylation aging clocks, which aim to calculate age based on methylation. So here are a couple environment factors that have been proven to accelerate or decelerate methylation aging, which are healthy food and exercise. They decelerate your aging, so you're aging at a slower rate. And cancer risk and neurodegenerative diseases and BMI, those accelerate your age. So that sort of really hits the nail on the head in terms of what we want to define as a biological age. But the problem is in the models that were developed in the early 2010s are highly inaccurate because they were handcrafted. Maybe they're based on some linear regression or something, but they're not. They either work too well for some people and not well enough for others, or they're just overall, on average, highly inaccurate. And very recently, this has enabled AI to get into the picture with deep regression learning, which has been used to successfully predict the chronological age of healthy individuals based on methylation. And this is by the Deep Mage paper, which achieved a mean absolute error of 2.7 years predicting age based on methylation factors, which is a really good result, that means that if you're 20, it's going to say at worst you're 22. And the idea is that by predicting the age of healthy individuals, we can use that same model on unhealthy individuals or on the population as a whole to say this person is not healthy because their age is higher, is predicted to be higher than their chronological age. So if this model predicts very accurately for healthy people, it's actually going to predict higher for people with various diseases. So going into the actual problem, the big elephant in the room, the big issue is the data. And we have a good amount of data sources, and mostly about from this database called the Gene Expression Omnibus database, which allows us, it has a lot of research studies done on different diseases. And those diseases have control groups. And those control groups will enable us to sort of figure out what the average healthy person's age should be. The data itself from a data set like this consists of up to 800,000 methylation gene sites, or what we call CPGs. And we need to sort of take that data and press it down in a way that's useful for a model to predict your age. So we are using about 30 different data sets from the Gene Expression Omnibus, including data sets that predict multiple sclerosis, depression, ovarian cancer, autism, schizophrenia, Down syndrome, predictive breast cancer, etc., etc. And once we have those data sets, we take out the controls from those data sets, so the people who actually do not have the disease. And we need to process that data and format it in a uniform way. So that's an issue because there is really not a uniform way of it hasn't been uniformized in the actual database. So a lot of different data sets have different names for things. So you have to really sort of get down and crank at the numbers and figure out what means what in different data sets. We need to get the set of common CPGs across all data sets. So that is, if we're starting at 800,000 different CPGs for one data set, we need to sort of cross-reference across data sets, and that brings down the columns to around 25,000. And then we need to clean up all that data. That means taking out any missing numbers and nans, essentially. So what we have left is about 4,000 training samples of control individuals with 25,000 CPG columns and around 500 test samples. We also have columns that indicate the sex and the race of the individual. However, those columns are usually filled with missing values, so in the actual modeling, they're not very useful. And that leads me to the data issues that are present in the deep MAGE approach. So far, we've been following the deep MAGE paper sort of dot to dot, but we noticed a few issues with the way they're executing things, which is, in order to make their model more accurate for chronological age, sort of to prove their concept, they try to cram in as many samples as possible into the training data set. That means improper handling of missing values. They added zeros where there should be a missing value, which is really not the way they should be handled. They added individuals from the disease group of data sets, which is it's a kind of unbelievable, really, because you're trying to predict sickness, and you're actually adding people from sick groups into your training data. explanation for that sort of is that they're adding people with psychological issues such as schizophrenia and depression, but that's really not a good explanation because depression is actually highly correlated with methylation. So this is really improper use of data. They're also doubling samples. There are a few data sets that are actually like proper subsets of other data sets they're using. So some individuals are actually doubled in the data, and that leads to significant bias towards those individuals. So they're sort of sacrificing the usefulness for the product for the model for accuracy of chronological age, but that sort of leads to an issue where it's not biological age anymore. You're predicting it's actually chronological age, and the other issues include ethical issues. Andrew mentioned a little bit about that, such as not having enough race features and not enough sex features, as those might be actually predictive. And to sort of step back from Deep Mage's approach, you could say that they are only exploring what is possible, and thanks to their exploration, we actually have the proof of concept that this is able to work, and all we need is maybe a little bit cleaner data and maybe more of it. And finally, a little bit about the age representation issue we have. So on the left, you can see the training data set we use, which is highly biased towards individuals from the 40 to 60 years old, which might actually not be such a bad thing, because eventually a product will be targeted mostly towards those individuals. As individuals at the age of 30 and higher are those that are more interested in how fast they're aging. And on the right, you can see the validation data set we use, which is actually highly biased towards 30-year-olds and toddlers. So that's one thing we need to address going forward. So let's talk a little bit about the model. First, let's mention our tech stack. We're mostly using TensorFlow and Keras. And thus far, we are very platform independent. If we need any pipelines, we usually use Kubeflow. So we're very interested in using Azure as the way going forward in terms of compute and orchestration. So a little bit about the approach we're taking. We're using what's called a deep regression network. So this, I'm sure that everybody here is well aware, is a deep neural network. And those are usually made with the idea of classification. So you have 4 output layers here in this network, and those will essentially output numbers between 0 and 1, 1 being the label being accurate and 0 being the label being inaccurate. But in our case, we actually have a regression problem, because age is a number, and we want to sort of say what that number is. So it's really a simple idea of taking the classification neural network and just changing the activation layer at the end from a classification activation such as 10H to one of these regression activations, which are ReLU, ELU, and linear. So that's one of the first things we did, is change the activation function. And then we needed to reduce the dimensions of the inputs, because we have 25,000 of them. And with only 4,000 samples, using all 25,000 inputs usually leads to massive overfitting, because the model is going to see the data, is going to make connections between those 25,000 inputs that are really not there. So we really need to reduce the input size to sort of make sure the model is, as funny as this sounds, less creative. So to reduce the dimensionality of the input, we first take all of the 25,000 inputs and we train a model that has only one hidden layer, and we analyze that model and only take the top 1,000 inputs that are significant for the output. So finally, we have a model with 1,000 inputs and 4 hidden layers of 512 neurons, an ILU activation function, dropout of 0.3. So dropout is after every fully connected layer, we actually deactivate some of the connections at random every step. This is actually helpful against overfitting. And finally, a batch size of 128 we saw as best during hyperparameter tuning because it sort of leads to a more well-rounded representation per batch of the methylation. And here are our results. We currently have achieved a validation accuracy of 3.9 years. So this is a greater error than DeepMage, which achieved 2.7. And the reasons for that is that we use less data, but we use cleaner data. That's one of the reasons. The other reason is validation bias, which is one of the things on our to-do list. We need to tackle that validation and make it more representative of the overall population. And how to improve? We need to gather more data. That's pretty much it, which is representative of the healthy human population, both for training and for validation. So here is what we're going to do next, and here's the big picture of the project. First, we want to perfect this aging clock. This is done by more data. And then we need to add it to a suite of more specialized deep learning networks. So that means disease-specific deep learning networks, deep learning networks that have specifically target environmental factors. So how much does that McDonald's really sort of change your epigenetics? And then once we have that suite, we will use the customer provided data to better the model and the measure and to better measure activities which accelerate and decelerate aging. After that, we will create a self-improving personalized recommendation engine based on epigenetic data. So actionable items that tell you, okay, you're predisposed to skin cancer, and today Sophia has a lot of UV radiation, so probably not a good idea to go out today, or at least apply a lot of sunscreen. Once we have all that, we will also target pharmaceutical trials. There is a lot of research going on right now in pharmaceuticals, sort of picking out which drugs are more likely to succeed based on digital twins data. So that's one direction we're heading. And we need to add genetic modeling as well into the actual project, because we have epigenetics, but as Andre said, epigenetics only really counteracts with genetics. So there's a lot to explore in our future work. And really, to reiterate that this is just the beginning, because science has only began to scratch at the surface of what epigenetics can bring to the table. Current methylation measures can only map less than 5% of the full epigenome. And as Andre said, the World Health Organization recently declared aging a disease. So we're going to start curing that disease as a part of the scientific community. Thank you very much. And here is how you can contact us.
this way.
I'm really,
Please go ahead.
please.
It is time for our raffle. At the end of this event, we are very happy that our partners from Adaptives will actually have some interesting prizes for attendees. So I will invite John to say some things about this and to draw the raffle.
Hi guys, so we're giving away a couple of hammocks for those of you that are here. Yeah, just also like to say it's been a really great event. Yeah, really nice to talk to everybody, and yeah, hope there'll be a lot more of these soon. Thank you very much, Misho, for organising, and everybody else as well. I'll make the draw with our complex raffle system. So
You can ask somebody to draw it.
oh yeah, I've kind of drawn this one, but we can do for the next one. So the winner of this one is Boriana Petrova. Do we have Boriana Petrova?
She's somewhere here. I can take it for her. She's.
Yeah, of course, you can take for everyone.
Could you draw for the next one?
Okay.
Not that one, not that one.
This is the winner.
Wait, what?
Snezhana.
Just picture. Great. Thank you, John.
No, thank you.
Thank you for the great support. And I would like just to say again, thank you for coming. Thanks for all speakers. Thank to all partners, and of course, especially thank to all Data Saturday Plovdiv team for this great event. I think that it is something which we will continue many years to make again and again. And we will expect you after 1 month and a little more for Data Saturday Sofia, 9th of October. Thank you one time more, and have a good week.